training for students organized by the American Meteorological Society, Satellite Meteorology, Oceanography, Climatology, SATMOC Committee. This is actually the fourth year we're doing this. We started this in the 2021 during the pandemic time. And we always thought that our students in the summertime can have a lot of extra curriculum activities. And one of the things the SATMOC committee think is to bring some new data sets, new development, and new science that come out from the new satellite programs or satellite missions, and bring those content to our students who may not learn those from their standard, kind of textbook setting of learning things. And the summer is a good time to doing this. So this is our fourth time to do this. And definitely the community is growing a lot this year. And you can tell from the chat that we have the students and the younger generation around the world like to learn more about the solar immersion sensing of our environment and our planet. So this year we have 4 sessions, and this is actually the 4th session. And you can look at on the slide here that those sessions covers a wide range of topics, from the climate dynamics all the way to hydrology to convective weathers. And then today we're going to hear about the drought monitoring. The drought is really a pretty long-term phenomenon. You don't based upon the data in one day to call it we're in the drought condition. So it's a very special phenomena that satellite can reveal that to us. The session will last probably about 3 hours. So the speaker today is Professor Chu-Sung Wu, who is an associate professor in the geography and sustainability at the University of Tennessee, Knoxville. And he has been holds multiple positions, including a visiting academic scholar in Amazon, a senior research fellow from United Nations University. He specialized in geospatial data science and open source software development. Dr. Wu is particularly focused on leveraging big geospatial data and cloud computing to study environmental changes, with an emphasis on surface water and wetland inundation dynamics. He's a creator of several open source packages designed for advanced geospatial analysis and visualization, including GMAP, LeafMap, and segmented geospatial techniques. So he will have a website I will type on the chat, and you can learn more from him. And so it's a great pleasure for him to talk with us today. Before we let him to take the stage, I want also to thank the SATMOC working group to planning this meeting. And their names are listed here. And by the way, my name is Jun Wang. I'm a professor in the chemical engineering, and my background is actually in atmospheric science. So anyhow, we started this group and this idea a couple of years ago, and this takes actually, I would say, probably a half year of efforts in planning to deliver this content and the platform for you to study. So I hope you cherish the time and the effort here, but also really want to thank the working group on this one here, and particularly Megan Christensen, who has been organized the virtual links and sending the emails and all that, and he will also interact with you today by looking at the the Q&As that you can type your questions there. And the last but not least, we do have if you have missed some of the talks in the past, we do have the recordings for the past sessions that you can either take a picture of this QR code, and then you can later on to look for this online. With this, Professor Wu, you can take the stage now. I'm stopping the sharing.
Let me share my screen. Okay, thank you, Dr. Wang, for the introduction, and thank you, the AMS SATMOC committee, for the invitation. So today we want to cover how to use Google Engine Cloud Computing to do job monitoring. And I don't have any slides. It's all very hands-on. So I'm going to walk through step by step how to visualize data, how to get access data, and how to do some analysis at national scale, continental scale, or even global scale. I send the link in the chat. You are also welcome to scan the QR code here. I will lay it up for a minute or two. So for those of you who need to access the notebook, then you can scan the notebook, or you can click the link. You can also just type the URL, gmap.org. So this is a package that I created a couple years ago, right after pandemic. So it's around 4 years old. And so Gmap has been officially adopted by Google Engine. So if you're going to use Google Engine and use Python, most likely you're going to use Gmap, and it's going to make your life so much easier because you can visualize the data interactively. You can also analyze the data interactively. And so I'm going to show you how to get started step by step. So on the website here, on the homepage, then on the left side, workshops, and scroll down to find SATMOC 2024. So this is a notebook that we're going to cover in today course. And you can scroll down here on the right. You can take a look at the table of content, the things we want to cover. It's a lot of content, but I think the idea is that to introduce use some of the tools that you might have used or have not. And just a disclaimer, I'm not a Drought expert. Okay, I have not really done any research on job monitoring before. This workshop is basically I try to cover some of the data set that being commonly used. And so if you're already someone that's have used Google Engine, you might have not worked on applications in job monitoring, or you might be someone that is already an expert in job monitoring, but you have not used cloud computing. You might be wondering how it works. So hopefully you will find something useful out of this course. And all you need is just a browser. You don't need to install anything on your computer. So and if you already have some programming background, perfect. If not, you'll be fine. So once we set up the account, authenticate, then all you need is just click the buttons and then just follow me. You'll be able to see the result. Of course, you're welcome to customize the source code, and sometimes things may not work, but it's perfectly fine. So don't panic. The whole notebook is reproducible. So you're welcome to mess it up. If something goes wrong, you can restart the kernel. You can restart from scratch. Okay. So again, here's the notebook we're going to use, and there are two ways you can follow this workshop. If you're new to Python programming, new to cloud computing, the recommended way is to just use Google Colab. So Google Colab is a cloud computing environment provided by Google for free, and basically just like Google Docs, right? You can use to write text. Google Colab is more like a Jupyter Notebook environment that allows you to write Python code. So what you can do here, right click and then open a new tab. So from here, it's open this one up, and so you can see this is the same one that's being rendered on the website, and you can click the upper left corner here, table contents. So you can see the same thing here. You can navigate through different sections. So some of the sections you might see some images, some might have some source code. So it basically is a mix of source code and text and figures and images. So it's kind of like computational notebooks that allows you to render things, and then you can run things interactively. I will show you how to do that later. So this is one way to run the notebook. The second way, if you're already someone that's familiar with Python programming, you can also install packages on your computer. Since this is kind of beginner level, we don't have time to go through all the details about how to install the packages. And you're welcome to do that if you know how to do that. But I assume that all of you guys is going to use the Google Colab. So number one, the requirement that you need to have is to have a Google Engine account. And you can click this link here, right click, open Google Engine. And so I'm not sure how many of you have used Google Engine before. If not, you can sign up right now. It's free for research and education. So if you go to the Google Engine, earthengine.google.com, and upper right here, there's a get started. Again, it's free for research, education, and non-profit. If you use for commercial, then you need to get a license. But for most of us, if you as a researcher student, you can use it for free. So you can click the get started here, and then log into your Gmail account. Then you just click like register for Google Engine. And so you want to select this one, unpaid usage, and the project type here. You can select one. So usually you can just select academic research. Okay, and then next, you can create a new cloud project, or you can create choose an existing project. So if a new users, probably you don't have anything, so you might need to create a new cloud project. And the recommended way is to sign up using your Gmail account, a personal Gmail account. If you use any university or government account, you might not be able to create a cloud project because they disable that functionality. So you may need to just see if you can choose an existing cloud project from here, and just next continue. Okay, so those are the steps that I'm not going to demonstrate. You can just create, if you can create a cloud project, you create one. If not, try to sign up using a personal Gmail. Don't use your edu email address, because you might not be able to do that. But anyway, so follow the step to create an account, and after that, let me show you how to find your because you need to create a cloud project ID. It's free, but you might need to enter your credit card account, and it's free. Again, it will not charge you anything. But Google saying it's free, but if you use other cloud computing services, you might need to pay. So here, once you sign up the account, let me refresh here. Oops. The web page is not working. 1 second, let me redo it. Okay, is it just my browser? So click here, platform, and then code editor. Okay. You should be logged into your Google Engine account. So from here, let me move up a little bit here. What is this? So upper right corner, after you create the account, so what you need is this one, your cloud project ID. Okay, whatever cloud project ID that you need, this is the one that you need in order to run Python code. So once you create a cloud project, remember this one. Okay, we not use it again. This is just for the JavaScript, so we'll be use Python most of the time throughout the workshop, and so you need to get this use cloud ID. Once you have that, then you can come back to here to this notebook, and you can scroll down here. Oh, by the way, you might want to change your Google Colab to dark theme. So from here, right now, some of the iPad widget doesn't work very well, so I recommend that you switch to the light mode. So what you can do here is to upper right corner, open settings, and then from the side here, the first one, change to light, so that you will see the same interface. Otherwise, some of the buttons might not look very well, so it's up to you. Okay, so once you have set it up, now you can first install the new package. So come to this one here, install Gmap, this one here, and let me see, I think I need to disable the indentation or something. Let me see here. Yeah, disable, because somebody drew something on my screen. How to? 1 second, let me clear my annotation, clear all drawing. All right, so here, just remove the hashtag at the beginning, and then just click this button, run it, run anyway. Then install all the packages needed for this course. Yeah, it might take a minute or two, but just let it run, and it will install the latest version. Gmap is actually pre-installed in Google Colab. Most of the time, you can just import it. You don't need to install. But because you're using some functionalities recently integrated into the latest version, it has not been installed here. So you might need some time to install it so that you will get the same result. So you will not run into errors. Just let it run. It should be done in a couple of seconds. If you run into any issues, you can have the Q&A, submit the question on the Q&A, or you can put it into the chat. So you see here, it's successfully installed. Then we are good to go. You can click this button here to clear the select output so that it doesn't take too much space. After that, go to the next code block, import EE and Gmap. So I'm going to import the Python libraries. Okay. And then the next step here, EE authenticate. You can run this one, and it's going to ask you to authenticate. Let me try this one. You don't need to follow me. I'm just trying to show you exactly the same. No thanks. True. So just EE authenticate and then allow. So you're going to open up here. It's going to ask you to log into your Google Collect account, and then just log in using your email account. Click continue, and then continue. Okay. So basically, what we're doing here is to allow Google Sensing to connect to your account. So hopefully, you should be done with this one. And next step here, EE initialize. So what this one is doing is first Google Sensing need to make sure that it's coming from you. And the EE initialize is that you need to make sure that you are not abusing their resources. So by default, you can only have 5 concurrent connections. So EE initialize to make sure that you have this one section connecting to the Google Sensing server. And most important thing here, this is the one you need to change. So as I mentioned earlier, in the Google Sensing, whatever your cloud project ID you name here, mine is called EE -book. You might be something else. So you need to get this name. So for me, I would be doing this way. Just change to whatever Google Cloud project that you're using. EE, mine is EE book. Okay, you might be using different name. So after run this one, if you don't see any error messages, you are good to go. If you run into any errors, then you need to fix it. Otherwise, you cannot follow. Okay. So after that, you can run this code block and make sure that it doesn't throw any error message, and then click this one. If you can see the map, you are ready to go. If not, then I can pause it a minute or two, and hopefully if you can see the map, maybe send a emoji or something that make sure that some of you can. Let me see if you can run this one here. Maybe give a thumbs up if you have successfully see the map. And you might be seeing an OpenStreetMap. Mine has Google Map because I have an API key already set it up here. If you don't have one, that's fine as well. So it doesn't really matter. If you want the Google Map, then you need to have a Google Maps API key. So it's up to you. But as long as you can see the map, then you are good. Please take the process. So again, you go to your Google Sensing account. You sign up for a cloud project, and then get your project ID. And that's the one that you need to use. And once you have the ID, replace your project ID somewhere here. Okay, so hopefully it works for you. If it doesn't, you can still follow through. You can just watch, but it'll be more fun if you want to play with the code. And so this is the most critical step, is to authenticate and initialize. And after that, we can start doing a lot of cool things. And again, you're welcome to just click through here. For example, run this code block, run the other code block. So we're going to create a lot of maps, and I'm going to show you how to access those data using Google Sensing. So again, you can customize. Right now, just the map. We don't really see any satellite data yet. So from now on, I'm going to switch to my local Jupyter Lab environment. It's the same thing. So, but it's much more smooth because it's running here locally. So I'm going to run this one just to show you here. Okay, so I'm going to do the same thing. And let me zoom in a little bit so you can see a little bit better. Okay. All right, so I'm going to create a map. And again, so by default, it's very simple. Import Gmap and then just create a map. And so this is the interactive map, just serving as the base map. Upper right here, you should be seeing this toolbar here allows you to, for example, change the opacity of the map. You can also turn the layer on and off, something like that. Also, there are some other buttons in here. So pay attention when I zoom out, right? You will see upper right corner here, that button is like flashing because it's loading the layer. Right now, it's very quick, but later when we do some loading and satellite data, it might be buffering until it's finished. I will show you later, but for now, like, so if you want to customize the map, right? So you can choose the center, the latitude, and also the longitude. So, and also the zoom level. So most likely, if you want to center your area around somewhere, for example, in the US, 40-degree latitude, 100-degree longitude, zoom level 4, and also the height. So it's up to you how you want to center. And also you can turn different controls. So by default, we're going to have this toolbar control here, upper right, that allows you to source data. I will show you later. But you can also here, you can zoom in, you can zoom out. You can also turn this one on and off. So by default, it's going to show you the layer. Right now, it's just the base map, okay? And you can, there are also multiple buttons in here. We may not use all of them in this course, but you're welcome to try that out later. So this is how you can create an interactive map. You can also add some base map. So there are multiple ways you can add the base map. So the first one is here, is to specify the base map parameter. So for example, Esri world imagery, for example here. So now you can see this base map directly. Also, you can just use the add base map function. So just map.add base map. So at any time, you can just type your code. For example, M represent the map object, and then type period, and then hit tab on your keyboard. You should pop up the list of functions available for the map class. So for example here, add base map, and then parentheses, double quotes, and then open topo map, something like that. So if you run this one, you see the map object is at the above. So you can actually load the data layer on top of that. And again here, you can turn layer on and off, and you can change the opacity easily. So these are not Google Engine. These are just some simple base map that you can add from the internet. Okay, and also you can change into a map interactively. So if you run this code block, it's going to add a base map selector. So the base map selector looks like this. So you will see we have a lot of base map available. I think it's over 140 base maps. So you're welcome to change any base map you like. For example, dark matter, okay, and maybe gray. And you can also use some, for example, open topo map, for example. And there are also a couple of Esri base map available here. So world imagery, for example, and position, right? So you're welcome to try it out. These are the base map that you can choose. And then once you decide the base map, then we start loading some Google Engine data. So let's move to the next one. So Google Engine data is different types of data. So these are the 5 common data types you want to deal with: image collection, geometry, feature collection. And this is very much similar to the vector and raster data format that we encountered. So image is basically just a single image with one band or multispectral bands. Image collection is kind of like multiple images. And usually in Google Engine, image collection is basically images coming from the same satellite sensor. For example, Landsat 9, surface reflectance, for example, or it can be lane cover, it can be anything. So image collection, you can think about is just a bunch of images. And geometry is just the shape. So basically the coordinates composing the shape. And the feature is that you have one shape and you also have some attribute. Feature collection is like you have a number of features. So you can think about a feature collection is just like a shape file, traditional vector data format. And then once you open a shape file, you're going to have different rows. Each row corresponds to one geometry. So that geometry has the attributes. And so we're going to deal with this because you need to familiar with this data format in Google Engine. This is how the data are being stored in the cloud. So the data not on your local computer, everything runs in the cloud. So let me show you how to access the data. So in Google Engine, everything starts with ee.something, ee.image, ee.image collection, ee.feature collection. And so let's run this one just to show you what it looks like. So what we are doing here right now, we are pointing to the SRTM dataset, the global SRTM. And if you print out the object, it's going to show you something like this. So you're going to see basically the metadata of the image. And you can see this image has one band. It's called elevation. And also it has a bunch of description in here. Basically the metadata, you can see the date. You can see some description in here. So if you need some data, you want to see the information, you can just point to that object and then just print it out. So next, how do we visualize that? Pretty easy. So here, we're going to create a map, and then we're going to pointing to this DM, and this is how we're going to visualize that. You can specify the minimum, the maximum, and also a color palette. And in Google Sensing, everything just like on all Sensing object, you can just add as a layer. So on your keyboard, you can press Shift tab on your keyboard. Oops. It doesn't work right now, but probably the shortcut is being occupied. If you're using Google Colab, it should be, if you have your mouse inside, it's automatically showing up, showing you the help documentation in there. And so what you need is basically the object and how you want to visualize that. And this is the name, the layer name you're going to use. So on the right here, right, take a look. Now I can see this one. I can turn the layer on and off. Okay, so pay attention to here. If you zoom in, pay attention to the button on the right. You will see it's spinning. So basically it's downloading the layer. So everything is coming from the Google Sensing server. Kind of like you are looking at Google Map or Google Earth. But keep in mind, we have direct access to this image. So it's like very, very powerful because we don't need to download any data. You can directly point into the data. So this, it can be, the analysis is just like you're watching a movie on Netflix. You don't download the original file, but you can fast forward, you can backward, you can zoom in, you can zoom out, and the data being downloaded on the fly. So this image, this DM itself can be maybe 10 gigabyte, but it's so fast in here because when you're zooming out, it's using a reduced resolution. So it's very tiny. When you zoom in, it's high resolution, but the area is much smaller. So it's downloading small pixels, small tiles. And this is, you need to understand, this is how cloud computing works. It's basically streaming the data on the fly. So if you really want to understand like where does it coming from, right? You can open in Google Colab, Google Chrome, more tools, developer tools in here. And then on the right, you should be able to see under the network tab in here. And pay attention, if I zoom in and zoom out, you'll be able to see this here, like image tile. So a small piece. So if you zoom in, you will see here it's downloading the tiles. And if you double click on that, it's open the image. So basically, the image that you see here on my screen is being combined, a combination of smaller pieces, and the data coming from Google Sensing. So this is why it's very, very fast, because it's just requesting data on the fly. And the image has already been requested, it's also stored on a local computer. But the nice thing about this is not just for visualization, you can do computation. So it's super fast. And let me show you, for example, right now you don't like this color. You can just remove this and then just change it to terrain. Just a keyword, just like terrain, and run again. You see, now I change it. So this is kind of like if you're in desktop GIS, you load the data layer, and then you, for example, QGIS or ArcGIS, you change the symbology. But in cloud computing, you can do it so much faster. You don't need to re-download the data. You can change it to anything else. So it can be Q1, for example. If you're familiar with Matplotlib cloud map, you can change it to any keyword. If that one doesn't exist, you will throw an error in here. So, and then you can change the layer opacity. Okay. If you don't like the layer, you can click this button, you can remove it and just remove the layer, then it's gone. So this makes it really interactive, and this is what Gmap is about, is to help you visualize the data very, very easy. Again, you can run it. You can change it. For example, I can say GIST Earth. I know this one exists, right? So you can, there's so many ways you can change. Also, you can change the minimum and the maximum. So for example, here right now you're looking at the US, the color is a little bit dark. So because the elevation is much lower, so you can change it to the maximum value, if you change to a low value, you're going to become brighter. Okay. So for example, if I change to maybe 4,000 and then run again, you see the US should be a little bit brighter because right now the maximum, basically you are stretching the value. So anything greater than 4,000 is going to be the color map on the right, and then smaller than 0 is going to on the left. So again, I can change it to maybe to 3,000. You can play with it. You can change the color, but of course in here in the Tibetan here, it's everything is higher than 4,000. So it's all like white color. So it's normal. So it depends on the area that you're interested in. You might need to adjust the minimum and the maximum. So at the end, you can see something like this. And again, the data is pretty big, but we're not downloading the data. We just visualize that on the fly. So you are pointing to the data. Each data set has a unique ID. So you can think about this is kind of like your, in the US, just like a social security number to each individual. So all we need to do is to figure out what's the ID for that image. Then you can get it, and then you can visualize that. So this is for single image. Of course, you can, sometimes you might need to deal with some time series images. So for example, if you're dealing with time series called image collection. So we're pointing to the entire Sentinel-2 image collection. So this image collection might have, I guess it's going to be over 10 million images, right? So it's a tons of images. And again, we're just pointing to that. Then you can do the filtering. So traditionally, you have to go to NASA or ESA to try to download the data. But now you don't need to. All you need is just tell the program that, okay, I want Sentinel-2 data. I want the date, acquisition date between in year 2023. And I also want the cloud coverage less than 5%. So that's it. And all you need is, okay, I want these images that meet my criteria. Then this is the power of Google Engine. You can just take the median. So the median means you might have some pixels that have high reflectance, some have low. So the median usually is pretty good because it's not cloud, but it's not too dark. So it's pretty decent. And once you create a composite, then you can do the visualization. Again, run this one. Keep in mind, this is at the global scale, so it doesn't matter where you are. It's filtering the entire the composite, the image collection that has tens of millions of images. So take a look at this one, and it's right. You can zoom to anywhere, and right now we are accessing this data on the fly. There's nothing. You don't need to download anything. But again, this composite itself, it can be hundreds of gigabytes because you're taking the entire year of data. You can zoom to anywhere you like, and right, and then you can zoom in because this is 10-meter resolution. It's pretty good, and you can turn the layer on and off. You can change the opacity. So this is how you can easily query data from the Google Engine data catalog, just with a couple lines of code. You don't need to download anything, and there are a lot more things you can customize. Right now, we are only using just one parameter, but you can do it right here. Let me quickly show you. I can, for example, I can just write collection and then just stop first. So sometimes you might not know, like, okay, what kind of metadata this image has. All you need to just print out the first one and then run it. Then from here, you can see the properties. So these are all the properties you can do the filter. So earlier, we only used the cloud coverage. For example, the cloudy pixel percentage, right? The first image has 8%, but you can use a combination of multiple properties. For example, acquisition time, the orbit, whatever, right? So low things you can easily do if you want to. And you can also see how many bands, right? From B1 all the way to something like that. So this can help you when you're trying to customize, do the visualization, right? So here we use B4, B3, B2. If you want something else, you can do that as well. For example, you can change to maybe to B8, for example, and 5 and 4. So you can customize, for example, B8, 5, 4, and run again. Right. So right now we are kind of seeing the first color composite. So it's easy. You can customize things pretty easily, and then find the best band combination that you want. Then you can start doing some analysis. So this is covers about the vector data and raster data, but raster data. Also, Google Engine has a lot of vector data. So let's run this one. So vector data is under feature collection, And then you want to see this one here, the unique ID. And so just pointing to the data, then just use the add data layer. So for vector data, the visualization is a little bit more complicated. But if you don't know how to provide, just put the empty curly brackets and then just run it. So again, this is the US census raw data. It's like many gigabytes. But again, you can just load it, just one line of code, and you can see the data without having to download anything. And so quickly, I want to point out, if you are interested in using some of the data set, but you don't know like where do I find those image ID, you go to the Google Search Engine homepage, and there's the data set in here. So what you can do is to click this data set, and it will take you to the data set homepage. So Google Search Engine right now has over 100 petabyte, basically 1,000 terabyte. No, 100,000 terabyte. So it's huge. So you can find all the image data, vector data, raster data. For example, earlier we used the Sentinel, right? So Sentinel has Sentinel 1, 2. So this one here, Sentinel 2, and Sentinel 2 also has different data products, Sentinel reflectance. So we are basically getting from here. So you can find the ID from here. Every image or every data set has a unique ID. So what you need to do is to figure out the ID, pointing to the ID, and then you can get access to that in your source code. So this is using feature collection. You can also filter the data. So in the data set, we have the US state polygons. You can filter, for example, either filter. So you can pass in the filter. For example, I just want the state of Tennessee. Then you can just filter it, state of Tennessee. So run it. Now you see you can get Tennessee. You can change it to whatever way you want. For example, I can change it to New York. Okay. You can customize it. Right now I get New York. So basically just vector data, and kind of like this is we select by attribute, similar to desktop.js. You can open the attribute table, and then you're gonna select one row, and then you can get the polygon. But in cloud computing, Google Search Engine, you need to write code. You do need to know some syntax. But again, I provide example in here. You're welcome to customize it. You can filter any data, and also you can select multiple states. In here, I have the US states polygon, and you can say e.filters in list. In list means if your name is in one of these, then I'm going to select that. So California, Oregon, Washington, for example, I can add one more. Maybe in Nevada. Right. So you're welcome to play with this. It's very flexible. So you can select any data, and then you can just plot it on the map without having to download anything. So this is for filtering by attribute. You can also filter by location. So what you can do here, for example, right now on this map, and I know the polygon covers the entire US. So for me, if I want to select, for example, okay, I want to select all the states covering the southeastern United States. I can home cover here, draw a rectangle or a polygon, or whatever way you like, and then just run this code block. And take a look. It's going to select all the polygons intersecting with the polygon that I just drew in here. So it's super flexible. Again, I can remove it. I can create it. And I can maybe draw somewhere here, maybe the northern United States, for example. Right. And run this code block again. It should select the other one. Right. So this is select by location. If you want something interactively, you can do it like this way. Lastly, I want to show you how to visualize the data. So if you, by default, it's going to be kind of a half transparent polygon. It's not very interesting. So you can easily customize that. So let me load this data set again, the US state boundary. So the entire state polygon here, and it's half transparent, but you can customize color and change it to whatever way you like. This is how you can do it using Google Search Engine. It looks a little bit complicated, but you need to get familiar with the syntax. But here, if you are someone really lazy, you don't know how to do coding, it's fine as well. You can just point to the data and then just add data layer and then use this default one. And after that, you can, let me run this one again. Okay. So I'm going to show you how to change things interactively if you don't know how to do coding. So what you can do here, now the data layer is here. You can change the opacity, and there's a button here. this button allows you to change visualization. So once it's pop up, and you can see opacity, the color. So for example, the outline color, you can change it. Maybe I change to green color. And also the opacity here, you can change the opacity. Maybe I change it to blue color, whatever color you like, and then click apply. You see, now it's being changed. So if this is something you want, you can certainly do it this way. So if you want just one transparent, you can change the opacity to 0 and then apply again. So now I only have the green outlines. It's hard to see. Maybe I change to red color and apply. See, so this is how you can visualize the data easily using GMap. So GMap has this widget that can help you do the visualization. And also there's an import in here. If it is import that allows you to copy the script and then you can use it in your source code. So after you click the import button, it's being copied to the clipboard. So then you can just paste it. It doesn't work. It might be a bug. I need to fix it. Anyway, so again, you can try to. Oh, it frees from my computer. Something is weird. Okay. Can you still see my screen? Looks like it's frozen. Okay. It works now. Okay. So this is how you can customize. The more complicated one here, if you can look at this example. Oops. Not this one. Scroll down here. Yeah, this is the last example. So if you want to create a map that based on a certain column, for example, you want to create some place map based on any values of a column, you can do that as well. But it's a bit more complicated. So certainly visualization in Google Sensing is not as straightforward as those desktop GIS you can just change, but you can use the GMap to do that. But if you want very precise, then you do need to write the syntax and then write some of these codes to get it. But we don't have time to cover all the details. If you interested in it, you can also look at the Google Sensing documentation. So this is how you can, this section shows you how to basically get some data, raster data, vector data, and then you can just visualize that. Basically, I'm showing you how to watch a movie. That's it. And so next, I'm going to show you how to find movie, how to find the data set that you want so that you can easily load the data. So let me see here. I think my screen is acting a little bit weird. Yeah. So sometimes after you run many code blocks, if it becomes a little bit not very responsive, then you can restart the kernel. So similarly, you can do that in the Google Colab. So I'm going to come here. After restart the kernel, then you need to re-authenticate. So I'm going to come to this one. Oops. Okay, and then I'm going to go to the Google Sensing data section here. Source data set. Okay, and I'm going to run this. So how do you actually find the data set, right? So earlier I mentioned you can go to the Google Sensing data set page in here. You can find data from here if you want to, but you can also directly do that within Google Sensing, within GMap. So under here, there's a button. So after you create a map, click this button, and then there's a data tab in here. So from here, you can just search any data you want. I can do, for example, elevation, hit enter. It's going to show you a list of elevation data set. You are welcome to pick any one you like. So I can do maybe SRTM, for example. Look at this, and it's going to show you the thumbnail. You can click the link to go to the description. So this is basically the unique ID to the image. You can click this import button to show you basically the script. So what you can do here is to just copy this one, Control C, and then you can come back to here, Control V. Once you paste the code, So depends on the map variable that you use. In the past, we used the uppercase map, but now we change to new convention using lowercase. So what you can do is just change the uppercase map to lowercase m, and that's it. Now you can run this code block. So simple and easy. So source any data set, get the sample script, and then just load the data, and then you can do the visualization. So this one right now, we are basically computing the slope or something like that easily. So very easy to do because you can source any data, and then just one couple clicks, then you can visualize the data. Okay, so this is how you source data. You can source any data. Okay, so for example, here I can go to the data again. I can source maybe Drought. And you see here, we have some of the Drought related data set. We're going to cover some of these later, but again, you're welcome to click this and look at example and then click, for example, import. This one is a little bit more complicated. I'm not sure if it works 100%. We'll show you some examples later, but for now, just assume that, okay, if you need some data, just go here. For example, I want US counties data set. Just source counties. County. Okay, or maybe country. So US counties, for example, here, 2016, 2018, right? And so I can, if you want some country boundary, you can click this one and scroll down here, click import button. And this is going to show you, for example, the data set again. I can Control C and then go back to the map. And then in the future, you need to change anything. For now, I haven't updated the package yet, but you just change the uppercase map to lowercase map. And take a look. So I'm loading the country boundary from the data set. It's again, you don't need to download anything. So this is pretty very detailed data set. Is probably a couple gigabytes, but we are loading the data set on the fly, and you can change it interactively. Okay, so this is how you source the data. Now we come to the first exercise. If you, for example, we cover how to filter image collection, and you can basically create cloud-free images for any location around the globe, and you don't need to really download any data. So it can be by country, it can be by state. Basically, you can create cloud-free images for any location of your interest for any time period, as long as the data is available for that reason. So again, you can try it out after the workshop. We might have time for you to finish all that, but you can follow the similar example. So all the source code, all the exercise, you will be able to find something from the sample code example that I provided, and then you can just most of those couple lines of code. So it's no more than 10 lines of code. So if you want, you can try it out. So this is covering the first, I believe, the first two sections. And so let me see here. So the next section will cover some additional tools that you can do the visualization and then create time series or something like that. So basically, some of the things that you might want to use, especially if you're dealing with a lot of data set, you want to create color bars. So we're going to take a couple minutes break, maybe 5 minutes break, and I'm going to answer some questions in the Q&A, see if anyone has any issues. So you're welcome to take a break and then come back at in 5 minutes.
You, Shang. We had a lot of questions about the initialization
Okay.
at the beginning. That
Let me take a look.
they were
So how to open the notebook, I can see
Hold
it
up.
collect, but not to be able to fix it. Let me see in yeah, so look, yeah, this is a common issue. So this the first step usually scare a lot of people away. It's because the initialization and authentication sometimes is like a little bit tricky. So I'm gonna quickly go over again. So if you're late to the party, then I'm gonna show you one more time. All you need to do is just a Google Sending account. So you go to the Google Sending website, and upper right corner here, get started. And so you do need to register for a Google Cloud project. So if you're new users, you need to register one. So register cloud project, unpay, and you can select the options. So for me, I'm going to academia, research, next, and you can create a new cloud project. So for example, right now I cannot do anything because I'm using my UTK email address. You should use your personal Gmail because I created a long time ago. So I already have the cloud project, so it's fine. But you can choose an existing cloud project. If you, in the drop-down list here, if you have anything, then you can select the one. So for example, here I can select or whatever cloud project. So this is basically the project ID that you need to get once you create a cloud project. And you might need to enter your credit card in some of the steps. It's free, you don't need to pay, but you do need to get this cloud project ID. So the other way is that if you already have a Google Sending account, you might already have a cloud project. So what you need to do is to go to your log into your Google Sending JavaScript code editor, and in the upper right corner here, if you click your the name the image of your the logo, your icon, there should be a cloud project ID showing up in here. So you can also use this one. This one is kind of like the Google default cloud project. So for me, it's called EE Book, and that's why when I come back to here, when you do the initialization, and for this one here, you need to put in your project ID. So again, I can write this one again and authenticate. So authenticate here is basically to Google want to make sure it's coming from you. Initialize to initialize your section, because you might open multiple notebooks at the same time. Google Sensing only allows you 5 concurrent connections. Otherwise, you are abusing the resources. So here, once you have these two, you should be good to go. So if you don't see any error messages, you are fine. If you see error messages, then you need to fix it. Okay, so that's about the authentication. Secret not found. So if you're in Google Sending, if the secret is not found, I can show you here on the left side. You can do it like this. So for example, you can add a new secret. So this way you don't have to, basically you don't have to enter this one all the time. So even in Google Colab, I can remove it. So you're going to get this one here. So what you can do is EE project underscore ID. And then from here, you enter the one you get from here, from your co-editor. So for me, for example, it's EE book. Whatever collection ID that you have, you can type, for example, EE, maybe a username or something. For me, it's EE book or something like that. So if you hit enter, because my project already have, so it doesn't allow me to create another one. So once you have this one, and then once you do the initialize, it's going to ask you to authenticate. So let me show you here. I can restart the section and import again, initialize. Sometimes it may not ask you again because it's already initialized. So you see right now it's like project not found. So I think the better way is just to write it out. So project equal to EE book. And sometimes Google Sending change the authentication or initialization methods. Sometimes things doesn't work, but if it doesn't, just either authenticate, either initialize, and then put in the project name here. Usually it should work. Any other questions?
Some other questions in the Q&A. There's a question about they see Colab, but not the Jupyter notebook.
How do I open the notebook? I can see Colab, but not Jupyter. If you're new to Jupyter, forget about that. Just use Google Colab. I'm running locally because it's a lot more smooth. So if you want, you can follow the instruction here to install Jupyter Lab on your computer, but it's not a requirement. Is it possible to add the leg long marking and labels on the map, like in grid inside? Yes, you can add some text. We didn't cover that, but you can certainly add text and things into the map. So, for example, here, let me show you. Let me run this one. And for example, create a map and then add a map here. Right. So if you want to add something to the map, you can do that easily. I can show you maybe here. Oops. Map.add and then maybe text or something. So it's add text, add images, add HTML. It's very flexible. So I can add text and then double click here. If you want to add any text or label, you can do that as well. So for example, I say hello world and then run it. Where is it? And then you need to display the map. Okay. You see lower right corner here, right? Now I have this label. You can add label, you can add images, but we didn't cover that in this workshop. Can I switch from JavaScript to Python in an easy way so that I have couple project using JavaScript? Yes. So if you if someone already familiar with JavaScript, if the JavaScript is not very complicated, you can certainly switch to Python. So the easiest way would be like this. So create a map and then click this button here. And then there's a button here allows you to convert JavaScript to Python, just one click. So if you click this button, and then you can paste your JavaScript. Again, if you just accessing the data, if your JavaScript doesn't deal with like interface or GUI stuff, you can convert it easily. So let me show you how you do that. So I'm going to go to maybe the Google Engine homepage in here, and then I'm going to go to the documentation. So basically, you can copy any source code from the documentation and then convert to Python. On the left side here, I can go to maybe image, and then image visualization. So in the past, most of the Google Engine documentation is JavaScript, but now they also have the Python version. So assume that if you don't have the Python, you can just come here, copy, and then come here, Control V, and then just do the convert. You see here is converting to Python, and then just Control C, Control copy here, paste. Again, you might need to change the uppercase map to lowercase map, but that's it. So M, and then just run it. You see, so I'm loading the data. So this is a very straightforward way that allows you to convert from JavaScript to Python. If it's taking one day for all the globe when you choose median, or does it doing the median for every pixel? So the median is taken by pixels, by location, right? So assume that you have 20 images covering this location. So the median is taking this pixel, all the images, for example, 20 images, 40, whatever. It's taking the median value for each band. So it's by band and by location. So if you, for example, have 20 bands, for band 1, it's taking all the 20 band 1 from here and taking the pixel. So median is usually pretty good for doing like creating cloud-free imagery. How to add a swap file for a specific location. We haven't covered that, but if you want to add a swap file, you can do it here. So again, assume that you have some swap file. So map.add underscore SHP. Oops. Why it's not working? So let me run this one, and then m.add underscore SHP. And then you can point to any swap file that you have on your computer. It should load the swap file to here. So let me see if I can show you quickly. For example, go to Gmap. Gmap have some sample data set here in the example data. And I may have, for example, US states, right? So US states, all this. Okay, plus this one. Oops. Sorry. But this is usually only good for small data set. If your swap file is pretty big, it's not going to work. If your swap file is only like a couple megabytes, it's fine. So for example, right now I have this US swap file, .SSP, and then I can run it. You see, so now I have the swap file here on my computer. So, but you have to keep in mind, this is local data set, it's not in the cloud. So you cannot really use this one for cloud computing. It's only for visualization, but at least if you want to overlay some data, not on Google Engine. So if you hover my mouse, you see it's on the right here, you can see the attribute. So this is one way you can visualize vector data, raster data locally or in the cloud, whichever way you want. How about regions in other countries? It doesn't matter. You can use any country, use anywhere. You can basically load whatever vector data you have. You just do the filter. So for example, you can load the country data set. You can select country, USA, Canada, whatever, UK, it doesn't matter. So all you need is just doing the filter. So if you go to the example here, and filtering image collection. So this is where you do the filtering. You pointing to the collection, and then you can figure out what kind of filter. It can be equal, greater than, less than. There are tons of examples that you can use. We need to copy some directory images from the presented GE project in order to execute image loading. No, you don't need to. Everything should be just a notebook. I don't need to provide you any data. Everything comes from the Google Engine cloud server. So if you run the source code, you should be able to get the same result as mine.
There's also a question in chat about adding 2 different data sets from Google Earth Engine.
How can we
say-
combine two data from Google Sensing, one from temperature, second from elevation? Then you just load multiple data set, I will show examples later when we get into the temperature data. But yeah, of course, you can load as many data layers as you want on the same map. So it's very easy to do. Last question. Changing the min max to make the data appear lighter or darker at the expense of making the region like super bright. In the example, do you have advice for creating global maps with the data selected region not look brown out? Yeah, that's kind of the you need to make some compromise, because if you're doing global scale, you probably, if you want to hide, it depends on area when you want to highlight. You can set a larger range if you want a global area. And the other potential is that you can change the value, right? So if it's somewhere is too bright, there's some outliers. Then in Google Sensing, you can change the value. For example, okay, anything greater than 8,000, you change to maybe 6,000. So in that way, you will suppress the range. You can do the stretching. So there are multiple ways you can do that. But if you really have some outliers too extreme, then your image is going to doesn't look that good. Or you can use a lighter color for the images. Or you can filter the images out so you only show a small area. But you do need to basically figure out, decide what do you want for the visualization. Okay, so looks like all questions are answered. So hopefully you can, by now, you know how to source the data, visualize the data. And so next section, we're going to cover how to use some of the stuff in Google, in GMap that can help you easily visualize the data with some additional tools. So let me go to inspector. Okay, so I'm going to come to this section. So run the first code block, and so let's get started here. So this one is called inspector tool. So the inspector tool allows you to inspect pixel values or vector data, raster data. So by default, let me show you how to access, right? So one question about like loading multiple data layers, right? So you see this example, we have multiple data layers in here. We have the US state boundary, we have the Landsat 7, we have the DM, we all have the base map. So the base map, this one is just base map, it's not Google Sensing, it's not cloud data set. The DM here, this one is cloud, Google Sensing, it's cloud computing. And so this one only has one band, this one is two bands, multispectral bands, this one is vector data. So once you load the data, if you sometimes need to inspect the pixel values or the properties, you can do it like this. So click this button here, upper right, and this gear icon, and then on the left side, the first row, first column, this is the one that you can inspect the pixel values. So if you hover your mouse and then click on the map, it's going to query raster data. For example, you have the elevation pixel values. You have the Landsat have 6 bands in here. You also have the vector data, right? So you can scroll down here to see the column. So this allows you to inspect values. For example, if I put my mouse right now in Texas, right? So I can zoom, click here. You're able to see like all the pixel values and also Texas. So by default, it's going to use basically, if your focus is on vector data, you want to turn this object on so that it's expanded by default so that you don't have to click it every time. So let me show you one more time. So we click here. Now you see it's expanded. So Texas, okay. And similarly, I can do maybe this one, New Mexico, right? If you just want to, if you have too many data layers, you don't want to show off them, I can turn the layer off. So for example, I can turn this data layer off. Right now, I only have the US states, right? So in that way, you don't have too many things in here. Again, I can turn this object on, and right. So this makes it easy for you to inspect the pixel values pretty easily. Again, I can turn on maybe just the DM, right? So I can come over here, click your mouse on the map, so you can see the pixel values. So all the data set is in the Google Sensing cloud, so it's not on a local computer. So under the hood, the program is getting your mouse click location, getting your latitude and the longitude, and then sending one to Google Sensing, and then create the result, and then pass the result back to the map so they can display in here. So this is how you can visualize the data easy. So the other way, I want to quickly point out, right? This is a DM. So if you want to change the color map, you can also do it from here, right? So we can change the visualization. Click this button here. It allows you to change the color map. So here, click the color map, and you can drop down. You will be able to see, for example, you can change it to maybe terrain, right? And apply. See, so now you change the color. So similarly here, like 4,000, you can change it maybe to 5,000. Hit enter, and then apply. Right, the larger the value range, the darker the color, because most of the value will be beneath that. If I change to, or use the slider, you change to maybe something like 3,000. You can change it. You can also change the opacity. If you want to change something transparent. So very flexible, very easy to do. You can change it to any color that you like. I can change it to gray color. Apply. Right, so by default it's gray color. So you can change images like this. I can turn this one off, remove the layer. You can turn on the lens 7. So similarly, I can change the opacity. I can also turn the band combination, right? So here I can change it to 5, 4, 3, apply. You see, so you're going to change it easily. You can change the gamma, right? So going to be a lot more bright, right? The gamma basically multiply your pixel values by this number. So you're going to get so much bigger. By default, it's probably too dark. So you don't really see anything. So you want the value a little bit larger. You can also do one single band. So if you just want to look at an individual band, you can select the band, and then you can select the color map. So again, you can select whatever color map you like. For example, this one, apply, see. So it's very easy to do. So this is kind of similar to desktop GIS. That allows you to change data layer interactively. So this is about the inspector. They also a plotting tool. So the plotting tool allows you to look at the spectral signature. So again, in this one, we have 2 data layers, Landsat and also Hyperion, hyperspectral data. So once you have this plotting tool loaded, you can select the data layer you want, then just hover your mouse on the map. So you can click. All right, so I'm going to show you the spectral signature for the image. And this is for Landsat imagery. I can turn it into the Hyperion. So Hyperion is hyperspectral data. So you zoom in, you click on the map, you should really see this one has almost 200 spectral bands. So you're going to have a lot more points. And you can also customize it. If you run this one here, egg marker is equal to 2, and then overlay. That means when you place your mouse on the map, you're going to get an icon, and you're going to, oops, this looks like a bug. Anyway, and you can also look at change the plot type. So for hyperspectral, this one probably looks a little bit better in here. It's weird. I think there's a bug. So sometimes it's going to show you multiple times. It's not supposed to be. Interesting. We'll fix that later. But this at least give a way to see the spectral signature if you want to inspect the spectral signature of the data. And next, legend and color bars. And this is also very common. So let me quickly run this one just to show you here. Right. So sometimes you're working on some lane cover data set. You might be creating some lane cover maps. So this is the legend in here. I want to show you. Right. So this one is the built-in. All you need is just one line of code in here. Use this built-in legend NLCD. So it comes from some of these in here. If it is not available, you can also customize it by providing a dictionary. But this one, we're just loading the base map. So this base map, the NLCD dataset, this is just a web map services. So it's not from Google Sensing. The second one here shows you pretty much the same result. But this image is a Google Sensing image. So it's in the cloud. You can actually use that for doing analysis. But we have the same thing in here. I can turn it off. And let me show you here. Click this button. You can create the pixel value, right? So this one is 82. 82 is cultivated crops, right? So you can zoom in. You can create the pixel value. For example, here I can click this one. Again, this is number 42, 24. So it's Drought lane, right? And the nice thing about this is like this image is like many gigabyte, but we are not downloading the data. It stay in the cloud. We can query the data. We can get pixel values. We can also do analysis, and then just one line of code to add this legend so that you can clearly correspond the color to a legend. So this is about the lane cover. And lastly, this one, again, you're going to get the same results, except that right now you can customize. So this dictionary defines the legend on the right here. So you can change it. So if it's something, for example, okay, this is open water. You don't want to open, you just want water. Then you can come back to here. Of course, this depends on your data set, depends on the color, depends on your real applications. It might not necessarily the same as the NLCD, but the example provide you a way that if you want to add a legend here, all you need is just create a dictionary. And the key are the text. And the next one, the value is the color, the hex color code, only showing up in here. So you have the legend, you have the color, you also have the text. So right now, for example, I change open water to water. If I run again, you see now it's only water. So this is pretty easy in Google. In Gmap is one line of code. If you're using JavaScript, this is going to take you many lines to create this one. So Gmap basically have this built-in, so much easier. Next one, color map, color bar. So color bar is like the legend is for discrete data, categorical data. Color bar is for continuous data, temperature, DM, soil moisture, whatever, continuous. So the one here at the bottom, lower right corner here, right? So you can see one line of code, just call the add color bar function and then passing the visualization parameters, minimum, maximum, and the color map. And then it will create this one. So for example, I can easily change this one. All I need to do is just maybe change it to terrain. Run this one again. And you see the color bar is being changed corresponding to the color. So I don't need to change this one actually. It comes from here. So you can automatically create. I can change it to maybe cool, warm, for example. You can do that as well. Again, you're going to change. So very easy. One line of code, you can do that. This is horizontal. So if you want a vertical color bar, you can add a color bar again and then specify the direction orientation to vertical. By the way, you can turn the layer on and off, right? And you can see the color bar is tied to the layer. So if you turn the layer off, the color bar will also be off. By default, it's horizontal, but I can change it to vertical. So if you run this one again, look at this. So now the color bar becomes vertical. So you can use it easily. Also, you can make it transparent. So I'm going to run this one. And now look at this. So now the color bar is transparent. So it's up to you what you want. This can be useful if you are dealing with continuous data and you want it to be a color bar correspond to your data, then you can do it like this way. Okay, so that's about the legend, and I have a couple. Okay, I think we're on track, so we should be fine. Next one, split map. So split map is useful if you need to compare data side by side. So look at this. So you can change the slider. So you have two different data layer. Right now, this is just a simple base map. So it's not very useful, but you can use it to do Google sensing. So look at this one. We created a map. We pointing to the NLCD lane cover 2001 and 2021. And then we just get the tile layer and then passing the tile layer to the map. So again, let me zoom in here. All right, so now this one, this is Google sensing. This is comparing the data, original data. And I can zoom into a specific area, for example, here, Las Vegas, right? And look at this. So the one on the left is NLCD 2001. The one on the right is 2021. So you can see the changes of the lane cover. You can turn the layer on and off in here to see the base map. You can also add base map, any other base map, for example, the Google satellite base map or Esri base map. So very easy to do. This can be useful if someone that you want to produce a map and then you want people to compare side by side, especially for some disaster or something like that. This is useful because you can sliding through to see the data set. You can also provide the label in here, right? NLCD 2001, NLCD 2021. So this is the label, the left label, the right label. So you can customize it easily. And this is one by one, side by side. But there's also another one here. This one looks complicated, but it can be useful if you are trying to, for example, have a grid of maps. So the nice thing about this, when I have move my mouse, it's linked together, so you can do it side by side. It can be 2 by 2, 3 by 3. It can be as many rows, as many columns as you want. By the way, this one, it may not work on Google Colab. So if we move a map, it may not move. So this one, you do need a local Jupyter Lab setup in order to see that. But it's nice because I can compare different band combinations. So for remote sensing images, different band combination can be used to highlight different features. So what I can do here is you can zoom in and zoom out. It's pretty cool. But you do need to write some codes. This one is a little bit more complicated, but you get the idea. So what I want to provide here is see all the things that I produce and then correlate to your own research, your own projects, and see if they, oh, I need this one, I need that one. So then you can just customize the data, customize the visualization, and then you can get the same thing like what I'm showing in here. So this is the split, the link map. Next one is for dealing with time series data. If you have a lot of data and then you want to visualize them easily, the time inspector and time slider would be useful. So let me run the first one here. So we are looking at the NLCD lane cover data set. So we have lane cover from 2001 to 2019. We actually have 2021, but it doesn't include it in this data set. So what you need to do is just one single line, the TS inspector. And let me run this one just to show you what it looks like, right? So we have 8 time series, 8 lane cover data set from 2001. You can add all the 8 layers to the map at the same time, but it's not very useful because you might have 10, 20 data layers. It would be better to use this time series inspector because you can have a drop-down list on the left. You have a drop-down list on the right. So in this way, you can select any 2 year and then you can do the visualization. So I can maybe zoom in a little bit just to show you here, right? So this is the US lane cover data set, right? I can zoom in. And so this one is on the left is 2000, this is 2001, and this is 2019. So you can see the changes of the data layers. You can select the drop-down list. You can change it to another layer, right? So I can change it to 2011. You're gonna see it changed, right? So pay attention, right? You can see that. So this provides a way for you to visualize time series data with this drop-down list pretty easily. So this is one way. The second one is using the time slider. So this one is even more interesting, and it allows you to add more data layers. So just one is called block. So we're using the NLCD, MODIS NDVI dataset, right? So this is daily images of vegetation index, and you might want to turn this one off so that it doesn't have a flickering effect. So lower right corner here is this slider bar. You can slide through here. So this one has a daily images for 30 to 31 days. You can click this play button to let it click through, but it might take some time because it's retrieving the data from Google Sensing. So it's not very smooth, but if you have a lot of data, you want to compare them easily, this might be a better way to do that. Again, this one may not work very well on Google Colab, so it might crash. Then you restart the kernel and try again, but you can install the package on your computer to see that. So at least you can use this one to visualize images for any location around the globe. So this is one way, and the last one I'm gonna show you. No, the 2 more. Okay, so this one is temperature data from NOAA. So I'm gonna get daily, hourly data, hourly temperature data. So this is 2018 December 22nd. So the temperature 2 meters above ground, and then you can specify the visualization and get the label. So again, lower right corner here, you should see the timestamp, and I can change it. So later I'm going to show you how to create some animation. For now, this is nice because you access to the original data, but we don't actually download the data, but you can just navigate through, and then you can see all the data set, see how the dynamics of the temperature change throughout the globe within a day. You can pause it, you can close it if you don't want to. So this is visualizing temperature data. Last one, Sentinel-2 data. So this one allows you to visualize images for any location around the globe. Sentinel-2, right? So you can, okay, I'm pointing to the Sentinel-2 data. I want to filter the data by a specific location, and I want the cloud cover is less than 10%. And then I'm going to, this is how I'm going to visualize that. So look at this. There are tons of images, right? Since 2018, all the images will be over here. You can just sliding through, you can see the changes. So if there's any specific location around the globe that has changes, you might want to use this one because you get access to all the images just with one click. So let me show you here. For example, I'm interested in looking at maybe I know there's some very dynamic river here in this area. Okay. So for example, let's say, okay, I want to look at this area. I want to get some images. So traditionally, you have to go to NASA to download data. But right now, you don't need to. So what I can do here is I come to this area. I can place a marker somewhere, maybe around here. Okay. And once you place a marker, you can create a new code block. And then just mdoc user ROI. It's going to show you the coordinates. Basically, this coordinate is here. So what you need to do is basically you just copying. This is the longitude. Okay, I'm going to replace this one. The longitude here. Okay, and similarly here. Then also the latitude. Oh no. Yeah, latitude. So latitude -8, and this one. Okay, so all I need to do is change the two coordinates, and that's it. Now, if I run this one again, it should come to this area. Take a look. So all the images that, I mean, you have to see a lot of cloud in here. You can change the cloud cover to a smaller one if you want to. But right, this is from 2019 onward. I can just slide things through. Basically, you get all the images for your area, and you can zoom in. So it's not just a photo, it's like the original Landsat data. So it's pretty cool. Makes it easy, right? Right now, if you want to study something at a certain location, you can use this one to quickly find the data, right? So if there's too many, the cloud is too much, you can change it to a smaller value. And if this band combination is also, you can also change it. So let me run this one. And see, so now we're going to have a smaller subset. So now the image quality is so much better. So you can use this way to find any images for a location. It doesn't have to be Sentinel-2. It can be Landsat. It can be any image. But the idea is the same. Once you get the collection, then you can just use this 8x slider. The variable name is not good. I need to change it. Kind of a typo. But you can basically filter data easily. So you can imagine this will be like, you're going to search a movie on Netflix. You can search by a certain category or by a certain character. So whatever name that you like, you can just search, and then you can get all the images all at once, produced at a certain time. Super cool. Okay, so that's all I want to cover for section 3, and there's a exercise in here. Again, you can create land cover map. So this is the one that I showed you earlier. It covers, for example, the legend, and do the filtering, and also the slider in here. Again, you can try it out after the workshop. So we have a couple minutes, so I'm going to take a break of 5 minutes, and I'm going to answer the questions, and then we continue to the next section. Okay, so first question, cannot load any images from collection. I don't know what specific, you need to be more specific. It's certainly might be just the issue from you on your end. As you can see, all images work fine on my end. So you need to be like exact, more specific about what collection or what images you are loading. Next one, consider two more data sets when exporting the output to Google Drive. The result would include two or more layers as a GeoTIFF or as raster. It's individual. So every data set in Google Sending is individual data set. If you can combine, you can merge the bands all together as a single file, then you can export as a single file. So it's up to you. In this workshop, we don't have time to cover exporting data, but you can go to the GMAP website, and then there's a book in here. So I published a book last year. If you want, you can, it's all open access in here. If you want a part copy, you can buy the copy from the publisher. But in a chapter here, chapter number 7, this one shows you how to export data to Google Drive to locally, a bunch of images or just one image. So there are different ways you can export the data. Also, recently, I think just last week, no, not last week. Yeah, last week, I have presentation at the SciPy conference, and there's a workshop in here. If you go to the SciPy 2024, this one also shows you how to export the data. So vector data to data frame or raster data to X-array. So there are multiple ways you can export the data if it's something that you want to do. Can we say that GMAP has to go straightforwardly to the export result by shortening the coding extent? I'm not exactly sure what do you mean by coding extent, but yeah, GMAP has is basically makes it easy for you to visualize the data, analyze the data. Next question: how do we download the specific image after processing it? As I just showed you earlier, you can come to the book and then follow chapter 7. So this one covers all the exporting data with vector data and raster data. Can we download results as imagery? It can work on ArcGIS Pro or similar. Yes, yeah, you can do that. Also, you can actually GMAP actually support Esri ArcGIS. So if you go to, I forgot which one. Let me Control C ArcGIS. Notebook number 131. This one actually shows you how to create an environment, install GMAP. So in that way, you can run GMAP within ArcGIS Pro. You can do it side by side. I believe I also have a tutorial on YouTube. So if you want, you can go to my YouTube channel. Oops. How to, I think, I forgot specifically which one. Somewhere here. Yeah, probably I have too many, so I forgot. But you can search my YouTube channel and then like ArcGIS Pro. You should be able to find the tutorial about ArcGIS. Yeah, this one. So using kind of like this. So this is demo, so you can definitely try it out. So on ArcGIS Pro, you can install the packages and you can run GMAP. So all the data layer will be pulling into ArcGIS Pro. So in this way, you can use cloud computing, but you can use ArcGIS to actually render the data layer and also create some maps. So you essentially enjoy the base of the two worlds, desktop.js and cloud computing, if this is something that you want. So you can try out the tutorial. Can we see NDVI data and temperature data, time series visualization for small areas, say swipe? Yeah, you can just use the example data provide. Yeah, certainly it's possible. How to export this beautiful map to other desktop.js? Okay, I just covered it. So it looks like a lot of people are interested in exporting data. So certainly go to the book and then follow the chapter to do that. On my YouTube channel, I also have a lot of tutorial showing how to export data. I understand how to produce the slider for time series visualization. Great. Thank you. All right. So this looks like not too many questions. So that's great. And so far we have covered all kind of visualization tools. So those are some of the basics about GMap. There are a lot more computing power and functionality. So next, want to do some cool stuff. Then you can create some visualization easily. I'm going to re-authenticate again, import the GMap, restart the kernel. So the next section is about creating time-lapse animations. This one is useful. It's especially if you're doing like trying to see the changes around a certain area, then I can do it easily. So first, I'm going to show you how to create vegetation indices for any area around the globe, right? So well, here, let's say I'm going to zoom in to maybe, how about this? I want to look at Africa, okay? And what you can do here, you can use a drawing tool to draw anywhere. For example, I look at Africa, okay? Once you have that, then just run a code block, 2 more code blocks, and see what happens. So GMap has this function called modis NDVI time-lapse. So it's a multi-decade from 2000, for example. You can change difference to 2023 if you want to. And so it's going to process all the images and then generate animation like this. See how cool it is. It only takes you less than 10 seconds. So you can create kind of animation showing the phenology changes at the continental scale. It doesn't have to be NDVI. It can be any images. It can be any time series. As long as you have a collection of data, you can create this one pretty easily. And after that, you can download the data. So this one is being downloaded to your computer where your Google Drive is running, your local Jupyter notebook. If it's on Google Colab, then it's usually downloaded to the left side of the, let me show you quickly. So on Google Colab, if after you execute the call, on the left side here, the animation should be downloaded in here. So you can download this one to a computer if you want to. But look at this. So it's being downloaded to my computer. It's a GF animation. It's like 2.6 megabyte. I can open it. See, very cool, right? It can be, this can take you a while if you use the traditional way. Go to download the data and then do some data processing. This is 20 years of data. It's like monthly average aggregation. So it's very, very cool. You can do it for other areas. So for example, I want to do that for maybe a specific area, maybe in South America, for example, or maybe in the US. Same thing. I can just see here, draw a rectangle, and just run the same code block. I don't need to change anything. It just works. So if you don't provide, you're going to use default ROI. Otherwise, okay. So now you see, I'm creating this one for the US. Pretty cool. So you can see the changes throughout the years. So this is for NDVI, but you can do the temperature. So temperature is more relevant to our drought monitoring. Again, you can just run through that. You don't need to change anything. So this one, you can create a global dynamics, the animation, basically temperature changes for the entire globe. And it takes maybe 10, 20 seconds, usually this, and then you should get the animation. Then you display, right? So this one shows you the temperature, sea temperature changes in a year, in a couple of years. Monthly sea temperature changes. Nice thing, it also add the color bar at the bottom here, lower right? So if you want, like sometimes show the color bar, show you the temperature, then you can use this one. So this is the MODIS ocean temperature data. The last couple one here, this is more interesting. So the GOES data set is launched by the, NOAA. So it's for doing like weather monitoring, weather forecasting. So you can use it to create animation for hurricanes, volcanic eruptions, wildfire, anything. So pretty cool because it's very high temporal frequency. So let's look at this one. Just show you here. Just run these first 2 code blocks. So we're going to get in the data for specific time, 2022. And so this one is very high temporal frequency. So you need to be very careful because if it's a very longer time span, you're going to exceed the limit. And you might have seen this one on the internet. So this is the famous volcanic eruptions, the Tonga volcanic eruptions. And so you get the imagery every 5 minutes. You can capture this one. So now you see how many lines of code? It's basically 1 line of code to create the animation. You just need to specify the date and the time, what satellite do you want to use and what kind of basically the scan, what mode, because in multiple types. So if you specify this one and then specify the area, then you can create this kind of cool animation pretty easy. Most things is one line of code, right? So it can be volcanic eruptions. Let's try another one here. This one is the hurricanes, I think. So again, you need to figure out the area, the bounding boxes for the phenomena you are interested in, and then figure out the time. And so for ghost data set, you need to be very, very narrow. You don't want to be too wide because it's tons of data. So it might exceed the memory limit. And so some question about like how to export these animations. It's already exported. So this is the file path, right? And then you're going to show you here, the image has been saved to blah, blah. So basically it has been saved to my computer. So if you look at my computer here, right? Ghost animation, it's downloaded. So it's downloaded automatically. If you're running Jupyter Notebook on your local computer, then it's on here. If you're running on Google Colab, it's being downloaded to your current working directory here. So if you click this button, you should be able to see the GF animation. And then after that, you just click this one, download, then you should be able to download this one to your computer. So this is volcanic eruptions, hurricanes, and the last one, wildfire. Okay, wildfire, again, you just bounding box, the date, and then ghost fire time lapse. So basically, you can not only check the dynamics of the wildfire, you can also begin the wildfire boundary, basically the evolution of the wildfire. And it's super cool because traditionally this is not very easy to do, but now look at this. This is the wildfire, and you can see the pink color, basically the pixel surrounding the wildfire. So you can see the evolution combined together, and you can also have the timestamp. Again, everything is downloaded automatically. So I can open this one up, and then you can share on social media. So this is some cool ways that you can create animation. Again, it's not limited to ghosts or slaying. It can be any satellite. It can be any image collection. It doesn't matter. As long as you have an image collection, then you can do that. So then in the next time section, I'm going to show you how to create animation for drought monitoring, for example, to see the drought dynamics. It's very cool. So, all right. So this is a simple one. Again, there are a lot more. We only show you how to use some of these weather climate satellite. If you want to learn more, you can also, again, check out the books. The book has a lot more examples. So if you go to the book and then chapter number 9, this one has covered a lot more. Let me show you here. So you can have NARP, NAP imagery, Landsat, Sentinel-1, 2, MODIS, GHOST. There are a couple more options in here. So there are a lot more examples. We don't have time to cover all that, but you're welcome to try it out to create more animations. So the next exercise, this one, you can probably try it out right now. So I'm going to show you how to do that. I'm going to just run this one. And then there's a function called add GUI time lapse. So if you run this code block, it's going to add this code block in here. And this one can help you create animation for any location around the globe using Landsat data. And then it's super cool, super easy. So let me show you, right? I'm going to zoom into any area. For example, I'm going to zoom to Las Vegas, for example, here, right? And assume this is the area of interest. Then all you need to do is just click the drawing tool here, and then draw a rectangle somewhere here. That's it. And after that, you don't need to do anything. Just click create time lapse, and just wait. You might need to wait 20-30 seconds, but you will get the animation. So what it's doing is get the area and then go to Google Sensing, do a filtering the imagery, and then do the data processing, removing the cloud, and then create the imagery for every year. So basically, you can create by year, you can create by quarter, you can also create by month. So it's up to you the temporal frequency you want. So this 10 Landsat data, we have almost 5 decades data from 1984 to right now. So take a look, right? Within 10-20 seconds, now we have the animation. Right now we have the polygon here, so it's kind of a little bit blur. But on the left side here, you can click this delete layer. You can remove it. Take a look. So now this is it's alive. You can see the imagery, right? You can zoom in, you can zoom out. You can even turn the layer on and off. So how cool is this? So you can basically make anywhere, I mean, any location you like, make it live by getting the Landsat data. And you don't need to do any data processing. So this is very computationally intensive, but we're using the free cloud computing Google Engine, and then we create animation. Again, you try it for any location you like. It doesn't have to be here. I can zoom to, for example, the this area that I showed you earlier, right? So this is a very dynamic area. The water, but basically the river, it's very dynamic. So what I can do here, for example, I can again draw a rectangle somewhere here. Okay. And that's it. After that, again, create the animation. So you can also create indices, but for now I don't want to worry about that. But you can also change the bank combination. So for me, I can change it maybe to, how about this one? Okay. So there are a couple bank combinations you can change. And after that, just click and then wait for it to finish. So this is super useful because before you're doing any research, you might want to see the changes. See in your real eye before you spend time trying to download the data. But of course, all the data can be accessed by using Google Engine. But if you can create some animation just to showcase the changes first, before you're trying to download large amount of data, it can save you a lot of time. See how cool is this? Like, and you can zoom in, you can zoom out. Let me turn this one off. Right? See how dynamic is the river in 5 decades or 4 decades, right? 1984 to 2024. And you can create this 10, 20 seconds. Then it can be Sentinel, it can be Landsat, it can be anything. So it's up to your imagination. Again, try to use this one to create some cool animations and show on the social media. And then have the hashtag GMAP or Google Engine. You can tag me, I can help you share this one on social media. Right. So very, very cool and very useful. And you can use this to explore all kind of phenomenon that can be captured by satellite data. All right, so this is all I want to cover about the basics using Google Engine. And I think we use 1 hour and 45 minutes. So in the remaining, we're going to get really into drought monitoring. So how do we use those drought data set to do some analysis, do some visualization pretty easily? Okay, so I'm going to take 5 minutes break and I want to answer questions. Then we can come back now, continue the next section. So again, I'm going to just to skip this one. Only a couple questions. How to visualize this time series result in graph form? I'm not quite sure what do you mean by graph form. It's time series images. You can plot one by one, or you can create animations, or you can do some analysis to get some graph. It's up to you. Second, can you please do for a small area? Yeah, of course, you just draw a rectangle on a small area, then you do small area. But it depends on the data set. If your resolution is very coarse, small area doesn't really, you only have a couple pixels, so it's not very useful. Depends on the data set. If high resolution, then you can do small area. But coarse resolution, certainly just a couple pixels doesn't really show you much. In ghost data, do you have PR or ET data that we can visualize that? I'm not quite sure, but you can check out I don't know exactly what other data set that they have, but you can just go to the Google Engine here, and you can view all the data set, or you can here ghost, just type ghost. You can see all the data set available in here. So I only use one ghost 17, but you have 18. You have couple others in here. They can try out. Next one, could you tell me which database is best for observing changes in surface temperature during the day at city scale? City scale, you probably need very high resolution. Again, it just come here temperature and let's search it. You'll be able to find some data set. So for the continental global scale, the EIA5, and then we're also going to show you some temperature data later, but some data related to drought monitoring. But for city scale, you probably need some high resolution. Certainly, Landsat or has some temperature data, so you can thermal data. So you might want, the best one probably highest resolution will be Landsat thermal. So you might want to find, for example, Landsat 8 or 9, and then get the thermal bank. Then you can do the inversion. MODIS also has temperature, but it's 1 kilometer, so it's not very high resolution. Can we study a river path by superimposing more than one image on top of another so that you can compare them? Yeah, of course. Yeah, you can load as many data layers as you want. Can we study flash floods using this? Yes, of course. I also have some videos and tutorials showing you how to do that. I actually have some notebooks. Let me show you here. Share. Here's how. I have some notebooks showing you how to do like flood monitoring, for example, Pakistan floods in here. So if you're interested in, you can use Google Sensing, you can get the data, and then you can oops, interesting. This one doesn't work right now, so I need to fix it. But so that you can get the flooding, and then I send the link in the chat. So you're interested in, this is all using Google Sensing, so you can customize to any area. Flash job, yeah, as long as you have data, you can do anything. So it doesn't have to be specific phenomenon. So the data, the problem is that do you have the data? If you have the data, you can do that. Can we calculate area of a landslide across the years? Yes. You have the imagery, you detect the floods, the slide, the landslide, then you can calculate. We don't. I might have some examples to show you later for the job monitoring. How much resolution for Landsat 8 and 9? It's 30 meter for the multispectral, and I think 15 meter for panchromatic, and so 30 meter resolution. Sentinel-2 is 10 meter resolution, so it's a little bit higher. Okay, I think I answered all the questions. Could you tell me which one? I think they want already answer. Okay, great. So we are on schedule. So we have 1 hour and 10 minutes. So now let's get back to business. Let's start doing job monitoring. So what we're really trying to accomplish. But hopefully, I mean, all the sections that we cover give you an idea how to get the data, visualize the data, exit the data, export some data. But it's only for visualization. So what kind of analysis can do? So Google Sensing actually, the most powerful thing is actually doing analytics. So I'm going to show you how to access the data. So specifically for this section, we're going to do job monitoring, and we don't have time to cover all the series about job monitoring. I'm just going to show you how to access data, get your hands on the data, and run some analysis. So if you want to learn more, you can check out some of the links they are providing here. Talk about different types of drought, hydrological, meteorological, agricultural drought, and also socio-economic drought. And different droughts can be monitored using different indices or satellite data. So specifically for this section, we're going to cover meteorological drought, basically how do we use those meteorological data to monitor and then do analysis. So in terms of drought data set, there are two catalogs here. The first one I actually recommend the Earth Engine Community Catalog. So this one is developed and maintained by my friend Sam Roy here. It has a lot of data set that not available in the Earth Engine data catalog. So you can try it out. You can just, for example, type here drought. You'll be able to source a bunch of data set. For example, US drought monitor, right? So this is one data set. On the left side here, also the North American drought data set, Canadian, and also the seasonal outlooks. These are all very useful data set, and it's being updated weekly. So the data always be most updated. So we can use that to run some analysis. Also, the Earth Engine public data catalog. So this one is officially maintained by Google Sensing. Different from the community, is maintained by the community. And Google Sensing also has some of this drought data set. We're going to use some of those, and I'm going to show you how to access the data and then do some analysis. And specifically for the US drought monitor. So although all the example I'm going to show you focus on the US, but you can easily customize to other area around the globe. It doesn't have to be just the US. And so specifically for the US drought monitor, we have different categories. So from D0 to D4. D0 means abnormally drought. So it's not really drought. It's like getting into drought. And from D1 to D4, these are basically moderate drought, severe drought, extreme drought, and also exceptional drought. And so you have the Palmer drought indices in here, soil moisture. So we also the standardized precipitation. So for this section, we're going to cover the drought, Palmer drought severity index. In the next section, we're going to cover the temperature, precipitation, the standardized precipitation index. showing you how to calculate. So the idea is like this. For drought monitoring, you can do everything from scratch. You can get all those meteorological data. You can try to calculate the standardized precipitation index or the vegetation condition index, and then trying to combine those all together to create a single index to indicate drought. Or you can directly use the drought index that people already created and use the satellite data and those image data. So I'm going to show you first how to access those drought indices. And then in the next section, I'll show you how some of those components are being computed. So if you want to get more in depth, you can do that. So anyway, this is the drought monitoring app that I would recommend that you try it out. So if you click the link, USDM Explorer web app. So this one again was created by Sam Roy, and you can go to anywhere in the US. So you can usually see the basically the dynamics of the drought changes by county. So again, this is a huge data set. So it's very fine, not really fine detail, but it's a longer time span. So once you open the web app, I can zoom into any location. So if there's any specific county that you're interested in, you can just simply just click your mouse on the map to select a county. For example, I select this county. I think this one is in New Mexico. This one is probably the Otero County or something like that. I don't remember exactly, but we're going to try it out. And again, it's going to go to Google Staging to pull the data and then doing all the aggregation. Then you can show the changes, basically how the drought is changing throughout the year from the very beginning when they start having the drought indices. So this one is already computed. Data that's already produced. We don't produce the data. We just pulling the data and then run the analysis, do the aggregation. And then, so look at this one. So it's starting from year 2000 up to right now, 2024. So we have almost 25 years of data, and you can see the changes, right? So the value from 0 to 5. So basically from 1 to, oops. Wait. Yeah, this is very intensive. So your browser might crash. I think because the data just become too much. So it may not work very well. If it doesn't, then just restart browser. But if we will give you a nice way to for all the drought data for any county in the US, so basically you can see what has happened in the past 25 years. Again, you can explore it, and so this one is just web app that allows you to see. But how about we get the data ourselves and then we do some analysis, we create some animation. That would be cool. So next, I'm gonna show you how to access the data. So again, you run this code block, this whole code block in here, and there are lots of data. I mean, within this one, and you see, so now I have the data. So it's a combination of multiple data layers. So first, let me explain, right? So we're using this drought monitor from the community data catalog, and we get all because the drought monitor data set is like bi-weekly. So we're getting all the data from 2023. So basically every week in 2023, you have one image. So we have all the images in 2023. I think we have 52 or something, 52 images, 52 drought images in last year. And then we just get the first one. So right now we're just showing the first week of 2023. So the image that you're seeing here, this one right now is the first week of 2023, the drought monitor 2023. And you can see here, I can turn this one. Oh, this is the US state. So this one here, right? And you also have the legend. So everything here, right, is what we covered earlier. So we have the dictionary. We construct the dictionary, and then we add the legend. And after that, we do the filtering. So we add the US. So this is the corners, basically the bounding box for the contiguous US. So we only get this portion. And then we can add the state, we can add the county. So this is the county. Kind of like what you see earlier in the USDM, the Drought Explorer, but it's the same thing. But right now, we will only show you just one image. But last year, we have 52, right? So how do we actually visualize 52? There are a couple ways. You can use the time slider that we show you in the previous section. Or you can use the time inspector. Or even cooler, you can create an animation. So let me show you here. First, let's get the time slider first, okay? Try the time slider. So if you run this code block, it's going to add the time slider to the bottom here. Look at this one. So this image, the first one is January the 3rd. Okay. I can change it to another different date, right? See that? How cool it is. So you can actually see the animation, the drought changes throughout the year. So we're loading these 52 images, 52 weekly drought images for the US. Again, it doesn't have to be US. If you have drought data from other countries, North America, all over the global, you can load the data, the same thing. So I think the more important thing is to learn how to generalize, right? How to use these tools. Location doesn't matter. The time spent doesn't matter. As long as you have the data, you can do it easily. So you can use these tools to quickly visualize the data from Google Engine. So this is one way you can visualize the data. And lastly, let me show you this one function, even cooler, gmap.create timelapse. So this function allows you to create timelapse from any image collection, any time series. So what we need to do is just to pass in this image collection. So this image collection is from here, from this one that we just filter, right? We filter from 22, basically the entire year, last year imaging, and then specify the date. So we only want the images from June 1st to the last day of 2023. So basically we get half a year, and then we want the region just within corners, and we get daily. Not really daily, is weekly, because we only have weekly data, but if you have daily, it will just get whatever images that you have. And how you want to visualize that, you also can overlay. Let me run this one first. You can also overlay the US state boundary on top of that. So, and you can specify the color and also specify where do you want to output the image. So basically just one line of code, and then it's going to pull all the data from Google Engine and then just create the animation for your data area. So this one is locked up data. So if you use the entire year, it's going to exceed the memory. So it probably doesn't work. But you can basically just create half a year and then create another half a year. And after that, look at this. It might take a couple seconds. Okay, it's done. So let me run it. See how cool. All right. So right now we're using Google Engine to process the data, download the data, and then show you the animation at the continental scale for the entire US. And I also overlay the state boundary on top of that and specify a color. You can easily customize the area, customize the date. It doesn't matter. You just call this function create time lapse, and you can do that for any location. Okay, so this is how to easily access the drought monitor data. Again, it's super easy, just a couple lines of code. Next, let's do a little bit more, because we are only visualizing the data of the drought indices, but there are also some other satellite data or other in situ data. There are lots of data on Google Engine, and so next we're going to look into like other drought data set related to this course. And we'll look into last year, July 2023, because NASA reported July 2023 was the hottest month on record since 1880, right? It's pretty hot. So you can see that at the global here, this is the temperature anomaly. You can actually do everything by yourself using Google Engine. You can produce this same image. Of course, it's going to take you some time to do the coding, but I'm going to show you how to access the data and then do some calculation and then see the job conditions. So for this following sections, we're going to use the GridMate dataset. So if you want to learn more, you can click the link, take you to the Google Engine website, and you can take a look at this one. So the dataset is from 1980 to right now. So the dataset being updated every couple of days. So you can see the latest one is July the 8th. So it's basically 1 week time lag. But you can look at the dataset in here. They have a lot of data. So SPI, see, they already have the standardized precision index. You don't have to calculate by yourself if you don't want to. You can use them directly. You also have these two indices in here, PDSI, the Palmer Drought Severity Index, and the Palmer G indices. So the PDSI usually is for monitoring long-term drought. The G index is more like for short-term. You can look into more details, like finding some references. We don't have time to cover all the details, but I'm going to show you how, for example, okay, how do we access or analyze this drought severity index for any location in the US. So here, I'm going to look into data last July 2023. So we are looking into the entire remade data set. This is again for the US only. You can replace it with other data set if you're working on other countries, as long as you have the data. So, and then we're going to filter the data, and then we're going to get a collection. Then you can look into this one. So this one shows you basically, like I said, this is like every 5 days. So the imagery has updated every 5 days, and it has a spatial resolution of 4 kilometers. So in July, we have 6 images, like 4, 9, 14, 19, 24, 29. So you have 6 images for July 2023, and you can also get the dates. So if you want, you can see the dates specifically in here. After that, we can calculate the mean. So what we're trying to do here is like, okay, you have every 5 days you have one image, but I want to create some monthly. We're going to get some average. So all you need to do is just to create this mean. So mean basically aggregate all the images into one image. So you're going to take the mean of all the images across all the bands. Then you end up with just one images. Again, this one has 26 bands, right? The PDSI, the G, and the SPI, now all the indices. So basically the original remade data set. So this remade data set has 26 bands. So you have 6 images. Each image has 26 bands. So when you calculate the mean, it's going to band 1, the Palmer drought severity index is going to take the mean of all the PDSI band. And then if it is SPI, you're going to calculate all the bands. So it's by band, and then aggregate them all together. So each band, you're going to end up with a result in one band. So in that one image, you're going to have 26 band aggregation from all the images. So once you have this, now we can do the plotting. So let's look at the data, see what it looks like. And here, I'm loading couple, because again, it has 26 bands. We try not to load all the bands. We are mostly interested in the PDSI and also the G, and also has some SPI, the standardized precipitation index, okay? By 30 days, by 90 days, 180 days, 1 year. So basically, when you are doing the aggregation, you can aggregate like within 30 days, 90 days, 100. So the longer you have, the more like the long-term trend, the shorter the aggregation time span, the more like short-term effects. So the precipitation has different like time range. So look at this one, look at the map. Let's look at this one first. On the right here shows you the different data layers. So you can welcome to turn them on and off. So I'm going to show you quickly. I can turn all the data layer off, turn it off, turn on the first one, and then maybe turn on the PDSI. So this one shows you the Palmer drought severity index for the US in July 2023, aggregated from those 6 images. You can overlay the states. So in here, the blue color represent the drought severity range from -6 to 6. So the more negative the value, the more severe is the drought. Again, if you want, you can go to the description here, shows you the detailed information. So this is what does that mean? Negative means drought, positive means wet. So from -6 to +6. So here, the red color here represent drought. The blue color represent wet. So you can clearly see this one here in July 2023. The drought area is here in Texas, and also some of the Midwest region in here, and it's also in Washington. The blue one means it's wet, it's not really drought. So, and you might also have the G index, right? You see it's very different. So because they use different time scales, so you need to make sure that you understand how do they come up with this data set, what kind of calculation. Long-term effect and long-term trend is going to be very, very different from short-term trend. It's just like climate and weather, right? So we're talking about climate change. We're talking about usually like 30 years, couple decades. Weather changes every day, okay? So weather temperature, for example, within a day, temperature can change 20 degrees from the midnight to the around noon. But long-term temperature changes at the longer time span, usually like 1 or 2 degrees is like a lot. So you need to be really careful about this. But again, this is just what the data set showing us. And again, red means drought, blue means wet, and G index it's very different. So this one is short term. Also have the SPI. The SPI is the standardized precipitation index. Again, the value range from this is more like standard deviation. So I'm not showing in the next section how to calculate this one. For now, let's assume that it's already calculated and let's just look at what it looks like. So again, pay attention. This is 30 days. So basically aggregate 30 days of precipitation. We have 90 days. You see, it changes. We also have 180 days, basically half a year. We also have 1 year. So you can clearly see the longer the time span, the closer of the pattern, the shorter the time span, it's going to be very different. So 1 year and half day, you want to see some similar pattern in here, although not exactly the same, but 180 to 90, 90 to 30 is going to be a lot of changes. So this is what the data is showing us. Again, even this 30 days aggregation of those 6 images throughout the July 2023. So this is what the data is showing us. And again, it's still just a visualization. So next, you can compare the dataset with other maps that's produced by agencies. For example, in the US, we also have this historical Palmer Drought Severity Index from NOAA, NECI. So you can clearly see the patterns. It's not going to be exactly the same. So there will be some differences, but it's fine because they don't necessarily just use the GridMap dataset. They use also other data sources. So the result might look different, but in general, the pattern will be similar. So look at this one, right? This PDSI is the one produced by NOAA, and this is the one produced by us. So we can see the patterns, it kind of is similar. The map is not big enough, so I can zoom in a little bit, zoom in a little bit, so you can see the differences. So you can compare the patterns, right? Here in Texas, it's pretty severe drought, right? Exceptional drought. This is a little bit, and also somewhere here, somewhere in here. It's not exactly the same, but it's similar. So the pattern is similar. So that means the data kind of makes sense. It's not 100% perfect, but you get the idea about using this data set to doing drought monitoring. So next, let's start doing some analysis, how to do the analysis for specific area or specific county. So for this one here, this one, and I will show you what does it mean. So what we're doing here, because we are doing the drought monitoring, we also have the US county, right? So if you recall earlier, I show you using the US drought monitor, you can select a county and then you can create the plot, the historic, basically the trend. We can do the same thing here. So let me just run this one and then let me show you. Create the time series, and then we can calculate the monthly time series for selected county. And you will see here we have 500. So this one we're doing for the entire time span. In time span? No, just from 1980 to 2024. Yeah, pretty much the entire. So because it's weekly, so we're getting the data weekly for that county. And then we have 534 images. So we also calculate the SPI, and I want to show you the result first so they can see, you can understand what I'm talking about. So let me run this code block. Whoops. And then we'll run some zonal statistics. So let's run this one. So right now we are looking at this county. So this is the county where Las Vegas is located. I think it's Clark County. And we have the PDSI for the months of July 2023. And then run this one. And let's see the result first. And then I will come back to explain what does that mean. So we can continue to execute and then run the computation. And almost done. Okay. So get the data frame. And let's get to this part. Okay. So this is the one I will show you. This is basically the PDSI historical values for this Clark County, where Las Vegas is located. So again, I mentioned earlier, the indices range from -6 to 6, right? So this is negative value, and this is all the historical from 1980s. So you can see the changes of the drought, basically the drought conditions for the county throughout the years. And also keep in mind, it doesn't really matter. The county can be any county, or you can draw a bounding box for any area. But the more data they aggregate, the more computation you want to power you're going to need. But this is pretty cool because you can see basically what has happened in the past, when it was really drought, when was it really wet. You can clearly see in the last couple last decades, right? Mostly drought. So in Las Vegas, we know it's like it's not a lot of water because it's in the desert. But certainly before 2010, they did have some like wet period. But you can zoom in, you can hear, you can hover your mouse, you can see the drought values. So basically, it's aggregating all the drought indices values within the county and then calculate the mean and then plot out this one. So this shows you the plot. And similarly, you can do the SPI, the standardized precipitation index. So similarly, you can see this one, right? The precipitation is more basically like more cycle compared to the drought. The drought is like, this is consistent drought, and here is all the precipitation. So you can see the total amount. So the precipitation is actually calculating the sum, the total sum of precipitation every month in that county for the past 4 decades. And interestingly, you can combine them together. Okay, so if you want, you can combine drought and also precipitation on the same graph. So you can see that like what happened. Like when you have more precipitation, is it going to be less drought? Yeah, looks reasonable. So if you see this one here, right, the red color represent the precipitation, the blue color represent the drought. So when you have more precipitation, it's less likely you're going to have drought. But in the last couple of years, it's kind of a little bit less. So clearly here, right, you see if there's less precipitation, less rainfall, more drought, right? So basically they should be along the same. If it's all positive, it's positive. It's all negative, it's negative. But of course, the drought indices is not only using the precipitation. They also use temperature. They also use other factors. So they might not be exactly the same. But overall, the pattern is like, yeah, if you don't rain for too long, then it's going to be drought. If you rain for a lot, then it's less likely going to be drought. But clearly see, you can see they're all under the same region. It's positive, it's positive, negative, negative. So this certainly can use this to use the existing data to basically study some of these drought patterns for any location around the US. If you use other drought data in the around the globe, you can use that as well. So then let me go back to explain some of these steps. So now you have seen this graph, right? Again, this is doing really analytics because we are just using a browser. We just run a couple code blocks. We didn't really download any data, but it gives you the power to access those huge data sets from Google Search Engine and just run the computation. It doesn't matter the area, so it can be a county, it can be a state, it can be a whole region, it can be a whole country, it doesn't matter. So the scale doesn't really matter that much. Of course, if the larger the area, the more computation, you might run into errors. But if you're doing a large area, you don't really need a high resolution. So you can use a coarse resolution data to run the computation. So let me go back to the data set here and explain what is this doing. So what we're doing here is that we select a county, right? Of course, you can do it. Oops, not this one here. So you can actually place, if you want to select other county, you can do that as well, right? So for example, I might, let's say, okay, I'm interested in this county. I can just place my marker, select a county, then the county is selected. Then you can run the code block again, right? So if what we're doing here is that if you don't select county, you're going to use the default one where Las Vegas is located. You can select another one, and then we're going to access the entire GridMate dataset, and we're going to select the PTSI, just one band, and we're just going to clip to that county. So clip to collection. So this is where the computing power, basically the map function is looping through, it has 534 images. It's looping through those 534 images, and then it clipped to your region, so that we reduce the data. In that way, we don't have too much data. So this is for PDSI, but we also do that for the standardized precipitation index. So basically, we're getting the drought and also the precipitation for our area of interest, and then you're going to construct all the data for us. And because it's bi-weekly, it's every week, right? 5 times 34, but we only want monthly because there's just too much data. So we can use the GMap to create time series and then passing these drought indices weekly, and then we're going to do the data processing. We're going to calculate the mean. So the reducer here means that every 4 images within the month, we're going to aggregate and then change it to the aggregation to the mean. So basically the mean drought. And similarly, we can do the SPI. Basically, you can do that. Also calculate the mean for the standardized precipitation index. It's a bit frozen. And so we construct basically the monthly time series for drought and also for standardized precipitation index. And after that, we can load the data into the map. Look at this one. Yeah, I think my computer is a little bit laggy. It's probably just have too much. Let me restart the kernel. It's not responding. 1 second. Let me restart. Let me rerun it. Analyze raw data set. So I'm going to come to here again. Anyway, you can customize it if you want. So I'm just going to quickly run through some of these examples. So we create the precipitation time series and also the drought time series. Again, you see 534. So basically almost 4 decades monthly, right? So every year we have 12 months. So you can multiply it together. So it's like almost more than 500 time series. And after that, you can visualize also. You can visualize just the first one, get the first images, and then it's still very laggy. So I'm not sure what is using too much memory. Let me see here. And so for this one, I'm just showing you, for example, the date. Just showing you that we have monthly images since 1980. So then you can filter the data to get any images. So for this one showing here, for example, I'm getting for the months of March 2021, filter the data and then just display it. So you can see here, this is the drought index, and the other one is the temperature, the precipitation. You can see here it's all red color. That means it's like it's in drought condition. So you can see the color bar in here, right? So red color will be somewhere between maybe -2 to -3. So that means it's like from moderate to severe drought based on the data here. Yeah. So mild drought, moderate drought, severe drought, extreme drought. So they're different categories, but just showing you basically just 1 month, and then you can calculate the zonal statistics. So zonal statistics means, right, this is one image and every pixel has a value. So you're going to aggregate all the pixels within this area and then calculate the mean. And this is why it's called zonal statistics. And it's going to generate a CSV. And next CSV going to have 2 columns. One column is going to have the band. The other column is going to have the drought index values. So for example, in here, right? So first band, second band, third band, and then you have the PDSI. Similarly, you can calculate for the standardized precipitation index. And right, so now I have the SPI, and after that, you can combine these 2 tables as a single table. But right now, this is just by the band name. We don't really have the date in here. And this is what this one is doing, is getting all the date and then create a date column, and then create those drought and standardized precipitation column. And this is what is eventually what we want. If you want to analyze the drought conditions for any location, you want to get the time series of those drought indices. You want to get the time series, the standardized precipitation index. You also want to get the date, and then with that, now you can create a plotting, right? So you can create this column and then use the date, the other column use the date, and you can also combine them together. So again, I'm going to run one more time. So this is pretty cool, you see. It's all interactive. So this thing makes it really easy to analyze any job data set at a large scale. Either it's by county, by state, by country, you name it. It doesn't have to be a single county. It can be multiple as well. So again, then I create a bar chart for precipitation, and I can also combine them all together. Right, and then you can zoom in, you can zoom out. You can save the images if you want. So this one here, once you combine as a data frame, you can also save this one to a computer. So if you want like to use it for further analysis, you can see this one here. This is the data frame. So it's a Python data frame. You can just dock to lowercase to CSV, and then you can just double close, for example, job underscore states dot CSV, and then just run it. Then on your left side here, you should see this one, right? States. Then you can open it. Oops. No, this one. Sorry. It's the other one. Again, my computer is frozen, but let me show you here. It's this one. Oops. So you can open it and you can see the 3 columns, right? So this is, you probably don't need this column, you can exclude it, but this is exactly what we need. And you can export the data easy, run in the computation, and then just export the result, just one line of code. Oops, probably this is too many column. It crashed my Jupyter notebook. Anyway, so that's all for this section, and we're gonna have a couple minutes break. Then I will answer some questions, and let me also restart my notebook. I think it's frozen, so I need to reboot it. Let me close it. Oops, it's frozen again. This is 534 columns. It's not that many. I don't know why. It's embarrassing. Let me close again. Let me delete this file first, so that it's not showing up. Okay, hopefully it works now. All right, and restart my kernel. Import the library. Okay, so done. And let's see, what questions do you have? Suppose I calculate a drought monitor for my country in Central America using precipitation, evaporation, and soil moisture for 2 decades. Can it show a similar plot of drought changes for the specific area in that time frame? Yeah, so you can basically, depending on whatever data you have, at the end, you can create a single index that combining multiple data, or you can just show, for example, precipitation, just like showing the changes for the area. Agree that, for example, what's the total precipitation for your area, for your country, for your county, or whatever, and then you can create a plot. So all you need is just doing the zonal statistics. It's actually pretty simple. So if you go to the analyze drought, and once you construct the time series, right? So you can use this time series, create time series function to create monthly, daily, weekly, hourly, daily, whatever you have. and then all you need is just this function, zonal state, and then passing the time series. Assume that you have the presentation for every week. So you have this collection, and then passing your area, and where do you want to export, how you want to aggregate. Do you want to calculate the mean? Do you want to calculate the sum? Or do you want to calculate the standard deviation, whatever way that you want? And it's going to export a CSV, and then you can use the CSV to create all kind of plots. How often make observation for this data, and which model make calculation for forecasting drought? So the data that we use, the green map, is every 5 days. So it's being updated every 5 days, and then it's using a bunch of other data set. So the data is keep updating. So you're welcome to check out here. For example, right now it's up to July the 8th, but if you check a later time, this date will be updated. So Google Sensing is pulling the data all the time. So that's why it's always up to date. Is this data suitable to study seasonal agricultural drought at field scale? Probably not. It depends on how big is the area they are looking at. This is the resolution is 4 kilometers. So the field needs to be at least a couple pixels, and you need to be maybe, for example, at least 40 kilometers, right? You need to have 10 pixels, so they have like, at least a couple pixels. Otherwise, it's one single pixel. It's local uncertainty. But you can use other drought data, for example, from Landsat or Sentinel, or some thermal data, whatever, or temperature data. That has a high resolution, then you can look at the field scale. But this is mostly for doing country continental scale studies, not really for micro scale. How to get color to the SPEI plot to differentiate between drought and wet periods? There you can add the color bar. So the color bar you can customize. So you can specify the color. For example, if you look at this one here, for the color bar, we are using this one, right? So the drought and the SPI, minimum, the maximum, you can change it. Or you can have 2 color bars, one for the drought, one for the weight, right? You can have from minimum from 0 and then to 3, the other one from -3 to 3. You can have a separate color bar if this is something that you want. Then you can separate 2 data layers. It all depends on how you want to organize your data. It's very flexible, so you can add 2 color bars if you want to. Do you have some recommendation about merging and aggregating databases with different spatial resolutions? Yeah, Google Sensing is like all the data are different resolution. They can all aggregate. So the resolution only matters when you do the computation. You can see we load a bunch of data. We load Landsat, we load temperature, we load DM. They are all different resolution, but it's all on the same map. So Google Sensing can handle different resolution without any problem. Okay, looks like I have answered all the questions. And any other questions in the chat?
Most other questions revolved around plotting from different locations, but I pointed them to the drought data sets.
Yeah, so the location you can customize. So it's you can select any county, whatever area, or you can draw a bounding box. It's easy. So most of the source code can be easily customized. Specifically for all the data set we're doing here, you can basically do it for any area in the US. If you do want to use other countries, then you need to change the data set. So what you need to do is to go to here, explore some of this data set and see if it has global coverage, then you can replace the data set. But the workflow is the same. You get the data, you do some aggregation, and then you run the analysis, and then you generate the results, and then you can plot the map, the result. What important points do we consider regarding the resolution when our aim is to use more than one data set with different resolution? Again, resolution doesn't really matter that much in Google Sensing. Everything is like you can deal with multiple resolution. The only thing is when you're doing the computation, we're getting something out. If you're just doing the visualization, forget about the resolution. It doesn't matter. if you're trying to computation, you need to aggregate the result, then it matters. Because imagine like the lane set global scale is 30-meter resolution. You are not going to run the computation on a native 30-meter resolution. It's a lot of computing. So when it's running, it's like based on your zoom level. If you zoom in, it's high resolution, it's a smaller area. When you zoom out, it's a larger area, but it's coarse resolution. So that's why Google Send is very efficient, because they subdivide the area into smaller pieces and send to different server doing the computation, return the result. So you can try to use the native resolution of the imagery for computation, but always keep in mind, if you're doing the global scale, don't try to use 30-meter to do computation. It's not going to work. Google Send is not going to allow you to run because it's hundreds of gigabytes of data. And so visualization, don't worry about resolution. Computation, then you do need to consider. You can try a high resolution. If it says that memory exceed, then you need to choose a coarse resolution. For example, 30-meter doesn't work, change it to 90 kilometer, 100 meter, 300 meter. You change it until you find the optimal one. If you really want to compute on a 30-meter resolution, then you need to do it for small county by county. It's going to take you some time. So, but sometimes you don't need that much detail. Then you just use a coarse resolution. You can run computation at scale. Can we use this kind of job to forecast forest fire risk? Yeah, you can. If you have some model, you can do the prediction. It's up to you. But this is just one data set. It's not like going to be perfect. You certainly need, if you for the fire risk, there are lots of factors. It's not just the job. It can be the surrounding. It can be the trees. It can be different types. It can be lightning or all kind of things. So you need to have some kind of model to do the prediction. But this is certainly one indicator. If there's a lot of job, severe job, more likely you're going to have maybe higher risk of fire. Okay, so we finished all the questions. So now we get into the last section. We are almost there. So I've covered how to analyze some of those existing job data sets. But sometimes you might want to calculate the job on your own based on some satellite data. You can do that as well. So this is the last section is about precipitation data. So assume that you have collected some data or you have some satellite data available, and then you want to, based on the precipitation, you know, figure out the long-term trend of the precipitation. So one of the popular one is called standardized precipitation index. Is that allows you to see how much precipitation are you away from the norm. So we can get all the data for the past couple of decades. We can figure out usually how much precipitation that an area get, and then you can compare yourself to the average. Kind of like this is all doing the global warming climate change. You're trying to figure out, or has the temperature increased like 0.5 centimeter as a degree or 1 degree or whatever, right? How was that calculated? Is you're getting the long-term mean, and then you see how far you're away from the mean. Kind of like in the US, we have the median US household income, right? So you're trying to figure out, are you a middle class or you're lower class or you're upper class? They need to have a baseline. Your baseline, for example, in the US, I remember exactly how much, for example, $60,000 US per year. If you're making more than that, you are upper class or middle class. If you're making less than that, you are lower class, like making less. So similarly, right? Precipitation, right? Rainfall. You want to figure out, like, in the past 30 years, how much rainfall do you get every month? And this is how we figure out, or is it drought or is it wet? Because you're getting low or getting less. So in Google Sending, there are also a lot of precipitation data set. You can click the link, you can go into here. Actually, there are a lot of data set available. We don't have time to cover all that, but we do want to have use some of the data set for you to demonstrate how you can calculate the job. But many of the data set are global scale, so you are welcome to try out other data set for your area. So specifically for this section, we are going to use the Prism daily data set to calculate the standardized precipitation index. So here I show you the equation in here. It's actually pretty simple. The current precipitation, the months of the current precipitation minus the mean, the long-term mean, divided by the standard deviation. So basically it's calculating standardized so they can figure out what how far you are away from the mean. And if you want to learn more information about this data set, again, it's started from 1981 to right now. So it's still being updated continuously. So the data set is, again, very much similar to the GreenMate data set that we use. So this is 4 meter. So if you remember earlier, look at this one. The GreenMate data set already calculated the standard SPI index, right? So for this one, it doesn't have, it just give you the PBT, the precipitation, the temperature, and some other parameters. So what we're doing here is how do we calculate the standardized precipitation index by ourselves rather than using the data that's already been computed. Sometimes it's not accurate or sometimes you have some issues, you want to figure it out. So this section is teach you how to do that by yourself. And so we are going to focus on this one, the PBT, and you can look at this one here. You can also look at some of the information, but the idea is that the unit is millimeter. So you're going to see here how much precipitation daily. This is not, I think, yeah, maybe daily, I forget. But we're going to aggregate the total precipitation in every month, and then we can compare, for example, to other data set. And then we're going to calculate. So first, let's just run this code block and see what we get. Okay. So we're going to run this code block. We're going to get the data set. We're going to filter the data to July 2023. Again, July 2023 was the hottest month on record based according to NASA. And we're going to select just the precipitation bank. So we're going to get all the data for July. And then we're going to take the sum. The sum means all the precipitation going to be added together. So if you have one like certain millimeter of rain, we're going to add it throughout the months, and then so we're going to generate one single image. So this is the color palette, the visualization, and we added all the layers. So look at this one. So this is the final map that's being produced. You see, it's a couple lines of code. Then we pull the data. So showing you here the color palette from 0 to 100 millimeter, and you can see. So basically, blue means more precipitation, red means less precipitation. So you can clearly see, right, in 2023, July 2023, most of precipitation is in the eastern United States. The western is pretty much like not much precipitation. This is also the county data set, so the state precipitation. You can zoom this. And again, we are aggregating the July 2023. You can do it for any month. It doesn't matter. It can be July 2024, for example. It can be 2020 July, or it can be August. It can be any month. You can customize it. You can even take the whole year. So if you're trying to figure out, for example, in last year in the US, how much precipitation did we have? Then you just change this one to July, January 1st to like December 31st. Then you get aggregate all year. So this is the power of using Google Sensing. Is I just change some minor things. I can get very different result, but it's the same. We calculate the sum, so we get the total precipitation. So think about this. You can aggregate any data at any temporal scale, temporal spatial, temporal scale, and it's super fast, right? So you can zoom in, you can zoom out. It's very detailed, and you can see the changes. You can see which area get the most precipitation. So this is by just 1 month, and then take a look at this one. We can even create time series for every month. So look at this one. If you don't select a county, so here basically was looking at a specific county, and then if you can turn on the county layer, and then you can place your icon on the map and then to select one county. If you don't, I think it's just going to look at the Las Vegas, the Clark County. And once you get the county, then we create the time series, and then we can just do the aggregation. So what we are doing here is that we select a county, and then we can get all the monthly images for that county, all the precipitation for that county. And so after that, we're going to get the reduced, calculate the mean. So think about here, we have so many months, and we're going to calculate the mean. So basically, we're going to figure out on average, how much precipitation do you get for this county for the past 4 decades? More than 4 decades, 43 years. 43 is every month. So if you calculate the mean, we also calculate the standard deviation. And then this is where we actually calculate the SPI, the standardized precipitation index. So what we're doing here, we're getting the data for July 2023, right? Getting the sum, the time series that we have this many time series. We take out this one, and then we minus the mean divided by the standard deviation. So basically, we are throwing this equation to calculate the standard precipitation index. Of course, this is just a simple calculation, but for more complicated one, you might want to fit to a certain distribution. You might need to transform the data, but right now, just for simplification, we just calculate, okay, how much rainfall do you get this month? How much, on average, how much water do you get the last 4 decades? And then this month minus the mean divided by the standard deviation of throughout the year, then you get the standardized precipitation index. So this is exactly what this equation is doing in here. So you can actually do the calculation for any area, any county, any month. It doesn't have to be July 2023. It can be 2020 July or April or December. It doesn't matter. Now let's visualize this one to see what it looks like. Oh, this is for the entire US. It's not just for county. So look at this. So now we are getting this precipitation, standardized precipitation index for the entire US of months, for the months of July 2023. And look at this. And of course, you can see the standard deviation, right, from -3 to 3, basically 99%. So most of those, if it is red color, that means it's drought. If it's white color, that means it's wet. Basically, you get more water after this, and you can change it. You can turn it on and off. This is just 1 month, but you can do multiple months if you want to. So this is a simple way. You can see how easy it is. You can create a time series, and then every month, then you can calculate the mean, calculate standard deviation, and then you can take out every month, every individual month, and then minus the what's it called? Minus the mean, long-term mean, and then divided by the long-term standard deviation. Then you get the standardized one. So let me show you here how easily to change, right? For example, right now I want to look at 2024. So suppose we have data right now is right, not the whole month here, but we can look at 2024, see how much water do we, how much the standard precipitation index. So we get 2024, and then June 1st to 2024, July 1st. July 1st is excluded. So basically the month of June, and you don't need to change anything else. Then we can just run again. You're probably going to see a little bit different. It can be any month. So look at this. So basically, last month, June 2024, we're actually missing some data also coming up, right? So you will see here, this is getting a lot more. So basically, if this one standard, if it's close to 0, that means you're getting pretty much similar precipitation as the historical mean. Basically pretty much the same. If you're getting more, then you are getting more rainfall. Red color means you're getting less, right? Kind of like the same example that I gave earlier, just like the income, right? So you can think about your lifetime. How much money do you make? So on average, you can, like, every month you are making some money, and you have the annual salary. So every year you're going to get more, a little bit more and more, but sometimes you might go down a little bit. So you can try, if you're trying to figure out, okay, on average, how much money do you make in your lifetime, 30 years? And when do you are making less, when you are making more, right? It's the deficit, or you have a surplus. So it is getting wet or dry, something like that. So this is a simple way that allows you to calculate. You can run all kind of equation. Right now, the standard precipitation index is pretty simple. It's just one example, but you can do that for temperature, for example. It doesn't have to be precipitation, rainfall. It can be temperature, it can be soil moisture, it can be wind speed, it can be anything. So as long as the equation, as long as you have low satellite data, you can create a time series, and then you can do some aggregation on the time series. You get some additional data set. Then you can use your current months to do some calculation with your long term. Then you can figure out, right? So go back to the previous example about I don't have time to show you all this, but for example, look at this one, right? Temperature anomaly. So how do they actually calculate this one? Is looking at all the data throughout the past couple decades, and then they calculate the mean, basically the mean temperature for every location, right? So in the last 100 years, this average temperature is this. So if you're higher than this one, it means you're getting like higher temperature, lower temperature. So the anomaly basically is your temperature difference from the mean, from the long-term mean. It can be 30 years, it can be a decade. It's up to you how you want to define the baseline. So the anomaly is like something minus the baseline. So our baseline, if it's 30 years, then it's a 30 years average temperature. Precipitation, it can also be 30 years. So it's up to you how you want to define. I'm just giving you some example. This is not scientifically like really sound. You need to do some transformation. You need to consider other factors. But in general, this is how you do this by step. If you do want to calculate this by yourself, and then you want to construct some drought indices on your own based on temperature, based on precipitation, based on other drought conditions, you can combine this data set all together to create the one that you want. But all the data is in the Google, is in cloud, so you can do that pretty easily. Again, the last exercise here is for you to use this data set to create, for example, the drought for a certain location. If you're only interested in a certain area, you can draw a bounding box, and then you will be restricted to just that area. Or if you're working in a county office, you just want a county, you can do it by county. Again, if you're using Google Sensing, most of the time the location doesn't matter. It doesn't matter how big is your area. It's the same procedure. It doesn't matter how long is the time series. The algorithm is the same. The more important is how do you come up with the equation? How do you design your algorithm? That's the more important thing. And then you can use GMap to pull the data, visualize the data, create this kind of plot, and then generate the outcome. So that's all for this course. And then we have 10 more minutes. I'm going to see if we have any questions. So you're welcome to type the questions. I'll try to answer all the questions. During the cloud masking process, significant portion of the images were obscure, resulting in data gaps. What technique can be employed to interpret or reconstruct? Yeah, missing data, like cloud coverage is always going to be a big issue. So depends on the area they're working on. If this like clouds is too much, sometimes you can just, it doesn't really matter. You can put all the cloud images together, just take the median, then usually it will be pretty good. But if like, for example, 90% of the time, if the location is covered by cloud, it's going to be challenging. But the nice thing about Google Sensing is by pixel, so it's not by the entire image. So even that pixel has 90% cloud, you can still get some kind of good quality pixels. So all the pixels are merged together. So in Google Sensing, so the images, then when you do the medium composite, every pixel comes from a different date. So if there's really a lot of cloud, you can increase your time span. For example, if there's like you only filter the data for the months of July and August. If there's not good enough, you can expand to April to June. You can increase the time span to get data, or you can change the filtering. It doesn't have to be median. You can say, I want to do the 75 percentile. That means you get a higher value if there's a lot very dark pixels, or you can get lower pixel, for example, 10 percentile. So there's some way you can work around that, but it's certainly an issue that you're going to encounter when you are doing a lot of images composite. Will be amazing to attend a workshop about G and PyTorch, focus on segmentation and gains. Okay, maybe next year or later this year. I do have some other packages. If you're interested in, you can follow me. Let me show you here. Maybe I have other packages, maybe called LeafMap, for example. And you can go to my repo. I have some other repo that's doing more like segmentation, AI related stuff. So it's under my open geospatial here. So you can follow some of those. I send the link in the chat. So there's another one doing segment geospatial. So this is more like AI segmentation stuff that if you're interested in, and PyTorch. But Google Sensing itself doesn't do deep learning. You need to export data to the AI platform, and then it's not free. So that's why I don't really produce a lot of tutorial on this aspect, because it's going to cost you money to run the GPU. But the segment geospatial you can run on Google Colab, use the free GPU resources to access some of those, do some segmentation. Next question. If we want such analysis for particular generated, maybe in my KML AI using Google Earth Pro boundary real estate, how to add the KML in Jupyter Notebook for analysis. So basically you have a local area that you want to get. Yeah, just I recommend you maybe just go to GMap and then click the books. Then here, there's a chapter number 4 using local geospatial data. So this one, there's also a KML section here, allows you to add the data. And so lastly, you can convert the data to Google Engine. So if you want to change the metadata, for example, GeoJSON to the EE, shapefile to EE or GTF. So it does provide some way for you to do the conversion. So if you want to. Can I get solar radiation dataset? Good question. I'm not quite sure. I've never really tried it, but again, everything is on Google Sending, so all need just solar. Yeah, this one looks like solar, right? Active radiation. So MODIS. I guess there's some others, so you can try it. Radiation, X-ray. So just search the dataset, search the website. And I think on this one I already answer. Getting the right data for task and location is very critical. Do we have a community to learn how to get some guidance? Yeah, the recommendation is look at how do people use. Most likely, whatever research you want to do, you will not be the first one. Other people must have done something. I can guarantee you. Just look at what data set do they use. Use some of the data set that have been traditionally used. If not, try to come up some relevant or come to Google Sending, source the data set from the data catalog or from public data catalog and see what kind of data are relevant. Or you can ask questions like what data might be suitable for your applications, for your area, then you find the data set. So it's not really like community. This is more like common problem. It's not just for geospatial. It can be any earth science or environmental problem. So it's up to you how you want to find the data. But in general, see what has been done in the past and then build on top of that rather than start from scratch. Okay, so we are on time. We have a couple more minutes. Let me see. We have more here. I hope to be connected with you in the future as help my project. So my recommendation is to follow GitHub, ask questions on GitHub. I receive too many emails every day. I usually don't have time to follow up on emails every day. But if you ask a question on GitHub, then you get answer. So for example, you go to GMap, if you find any bugs, you can report bugs. And also there's a discussion forum here. They can ask questions. So this is better because if you ask a question, you can search, see if someone has asked similar questions. And then if not, you can post a question. And then when I have time, I try to answer. So you see here, you usually get answers within a day or two, usually within 24 hours, but sometimes I'm too busy, I might not be able to, but you can certainly ask questions for specific Google Sending. You can ask here about GMap. So it's about Python, Google Sending, and GMap. For JavaScript, you have to go to the Google Engine developer forum. It's the different one, but I only use Python. So you're welcome to use this forum and then to ask questions. And then I think important is to learn how to ask questions, learn how to provide some sample example that makes it easy for other people to help you. Don't just ask a question. I want to do this. What can I do? It's too vague. So if you do something, you need to describe your questions, provide some sample code, and it can help you do the debugging, and it can provide some updates. So this is, the better way. If you really want to get some answers from the community, try to search, see if question has been asked. If not, have a description, have some sample code, and make sure that we can reproduce the error. And if there's a question, you can ask it here. If it is a bug, then you can report in here. We also welcome contributions. So if you know how to do coding, you're welcome to submit pull requests in here. Everything is open source, so we welcome the contribution. You can see all the contributors from here, and it has been used by. So Gmail has been used by over here. How many projects? I forgot. Like over 2,000 projects use Gmap on GitHub. So it's certainly a lot of people are using it. 2,800, right? So if you contribute, your source code eventually will be used by a lot of people. And also it's officially on Google Staging. So if you go to the Google Staging webpage, if you click here, Python setup, GMap is the official Python package for doing visualization with Google Staging. So you only use the core because GMap has a lot of functionalities. Google Staging team cannot support all of them, so they only have the core. But for you, you can just import GMap, you have everything. But GMap, the core is just for them to help them easier to maintain the core functionality of the package. And any other questions? How to solve the memory capacity limited scope in Google Staging? Yeah. Do a smaller area, do a smaller time span, use a coarse resolution, or do it step smaller by smaller. There's not really a shortcut. You need to figure out a way to do that batch processing. So that's a common issue because imagine I'll give you an analogy. It's a free resource, free computing resource. Just like you're going to go to the theater to watch a movie. And everyone is just shared resource, everyone wants to watch a movie. You cannot just say, okay, this theater is just mine for tonight. Nobody can use because it's a shared resources. So you need to like wait. They wait in line. You watch it couple 5 minutes, and then you go. Someone need to watch that as well. So you just need to keep that in mind, and then you can find some way in an innovative way to do the computation. You're just not going to be able to. Okay, I want to process 1 meter resolution, native resolution for the entire US. I want it right away. Yeah, it's not going to be possible. You just need to use just a thumbnail, or you want to do it step by step. There are a couple ways you can work around, but yeah, memory is an issue that you have to think about, and then the more you use it, eventually you become more comfortable dealing with large scale computation. But from all the examples I show you here, you see I don't really run into any error. I can do the continental scale study for the entire US. I can aggregate 4 decades of data without any issue. So it's actually already very, very powerful if you know how to use that. So I would recommend that you just follow examples, customize it, and then find some ways to replicate, and then do some large area studies. Last one, with rainfall forecasting in machine learning set data will be useful. Thank you. Yeah, you're welcome to use it. Everything is open source. It's always available on the website, so you're welcome to try it out. Again, if you find any bugs, you're welcome to let me know. I'll be happy to fix that. So a lot of workshop that I've given in the past is all here. I also have a YouTube channel that I produce a lot of other videos, not just Google Staging. So most of the Google Staging workshop
I'm in the midst of applying for residency right now.
actually, there's a lot of also from Google. I think I have some. Let me see here the playlist. So if you're really interested in, you can look at some of these that I have done in the past. They have all the recordings. So this one has a lot of like hours of but it's not specific to Drought, but it's more like Google Staging. So I've given a lot of works in the past at the conferences. So you're welcome to try it out. The first couple it was at Google last year, so Google headquarters. So it's high production quality, so you can follow those even to learn more. We only 3 hours, so we only actually cover a small section of what GMap can do, but there are a lot more functionality out there. Okay, I think I've answered all the questions. So it's 4 o'clock sharp. So thank you very much for attending, and I hope you find something useful. You will love to hear what you want to do with Google Staging and GMap, and you're welcome to connect with me on social media, ask questions on GitHub, and welcome your contributions. Hopefully, if time permitting, next year we can do something different. Thank you very much.